I do remember one time I logged into LinkedIn and it was this top post that actually made me laugh. What was it? It was like, this morning I went to an interview, but I saw a starving dog by the side of the road. So I stopped to feed the poor dog and I missed the interview. The next day, to my surprise, I was called in to try the interview again. I came in the next day and the interviewer was the dog.
At the beginning of the show, we talk about how to sample a language model. And then we just sample from these tokens here, like it's a probability distribution. Then we look at Melanie Mitchell's article on GPT-3 and character analogies. And this time it answered it correctly on every single trial. Then we test out GPT-3 with a substitution cipher. So we're expecting VCFOG, and we don't get that. We check out the database prompt example. When asked a question, if the answer has not been added to the database. Next, we see if we can use GPT-3 to predict the broader impact statements. You might have heard of these broader impact statements now, which have become mandatory. Yannic said that he felt that in practice, these broader impact statements, they don't really carry any information. So this is what Professor Gary Marcus had to say about GPT-3.
My take is that it's going to look like a mistake in the eyes of history. That it's really cool and really fun. It's an impressive piece of engineering, but it's actually a distraction from what we all want, which is artificial intelligence that we can trust, that we can count on, that's reliable, and that understands the world around it. What GPT-3 does is it takes a whole lot of statistical data generated by humans, and it's parasitic on all that data. And the data is of humans having conversations or just text in things like Reddit. And that text is correlated with the world. People don't just talk at random. They talk about the things in the world around it. But all that GPT-3 is really learning is correlations between texts.
Gary comments on the hype around GPT-3.
There is mass hysteria. So everybody, The Guardian, The New York Times, they've all got to run these, and The Economist all have to run articles about how cool GPT-3 is. They cherry pick the sample to make it sound better than it is.
We discussed the difference between pattern matching and reasoning.
Syllogism is a form of reason, where you take some known premises and you get to a conclusion that's guaranteed by those premises.
Yannic asked whether multimodal models could get GPT-3 closer to something that we would perceive as reasoning.
To say that GPT-3 doesn't do things like understand physics is obvious because GPT-3 has no notion of physics because its generating function that it tries to approximate includes no physics. Would you generally agree with that?
Gary thinks that we are being fooled by an illusion created by GPT-3, a parlor trick.
It knows nothing about physics. Its input does not directly refer to physics or psychology or anything else. And yet it gives the illusion that it does. Mm-hmm. And the real problem is that GPT-3 is almost like a magician, but you shouldn't believe that the magician is actually doing the trick. And you need to understand the difference between a magic trick and reality. It's just fooling you. It's just a trick. And that's okay if what you want is a parlor trick.
So looking towards GPT-4, we may find a way to not only input text, but to input images, like we have eyes, to input something like touch, smell, gravity, the experience of gravity, right? The experience of motion in the real world. We somehow manage to input all of this as a data stream into the same kind of system. Would you still consider that a magic trick, or would that come much closer to something you'd consider AGI?
But isn't pattern matching Turing complete? In some sense, there's no dichotomy between reasoning and pattern matching.
This is mumbo jumbo. So here are some actual facts. In the real world, that's not how you would do things. So in the real world, you don't have infinite data. So it's like a mathematical curiosity that basically is saying, I can memorize anything. Great, you can memorize anything. But what if you have to deal with something that you haven't memorized, that you haven't confronted before? Then those proofs do nothing for you.
Just like Walid Saba, Gary Marcus hones in on the missing information problem as being the fundamental issue stopping GPT-3 from achieving natural language understanding.
The real problem in language is that you don't say everything that you mean. It would be incredibly tedious if you said everything you mean. If I say it's on the table, it's probably not falling over now, but I'm probably not telling you that. And so part of the language problem is to do a bunch of inference relative to an understanding of the world. So common ground is a huge part of language. Having that background knowledge is important in interpreting what's going on. And GPT is just not helping with that problem.
Gary asserts that GPT-3 fans are just discarding decades of knowledge in computational linguistics.
There's a huge literature on this in, say, psycholinguistics about how you immediately take your world knowledge in order to parse a sentence and so forth. And the GPT-3 fans have just ignored that entire literature. It's like the ultimate in intellectual arrogance. We don't need to know linguistics. We don't need to know psycholinguistics. We don't need to know computational linguistics. We're just going to reinvent everything. We're going to make our sentence predictor do everything.
Gary also comments on how hard it is to impute fresh information into GPT-3.
For GPT-3, if you find out something new, you have to retrain the entire system. You want to be able to find out one new fact.
We also asked Gary what does he think about prompt engineering.
So what GPT-3 does is basically autocomplete. And by playing around with prompting, you're changing what the autocomplete problem is, but you're using the human knowledge to do that. There's not an internal system to do that. And then it's just like petitioning until you get the answer you want and then say, I found it, which is not good scientific practice. I really don't see that bright a future for GPT-3.
And finally, Yannic asked Gary a very interesting question about psychology.
Do you think there is anything about humans that we can learn from GPT-3, from querying it?
We chat with one of our favourite guests on the show, the charismatic and wonderful Connor Leahy.
I think GPT-3 is probably the most interesting thing to come out of AI in a long time. What makes GPT-3 fascinating is the scaling laws that we found. That we just make the model bigger and it just gets better in a very predictable way.
It's pretty good at storytelling. I was impressed with a couple of the poems that I got out of it. Would like to look at more is the data that goes into training it.
Connor gave us some insight on what he thinks GPT-3 is doing behind the scenes.
And it just refines this guess layer by layer by layer. This is, as far as I'm concerned, currently the best proposal for what GPT-3 is eternally doing.
This is what Connor said when I asked him about the apparent limitations of GPT-3.
It's the fish climbing a tree argument. You're barking up the wrong tree. Everything you say is true on a technical level, but it's missing the forest for the trees.
I pressed Connor in particular on the lack of reasoning in GPT-3.
We should taboo the word reasoning. Is that we should at least define the word reasoning.
Yannic had a really interesting thought about whether thinking is language.
What I find interesting is that when you think, it appears to you that you think in internal language. Like the whole process you described right now, that somehow happens as language in your head. You're talking to yourself and you go like, well, wait, no, well, okay, maybe that, and so on. And as of now, I still don't see something like GPT-3 doing actually that, like actually materializing its internal state as actual language tokens or discrete states or something like this. And there the question is, are we just post hoc rationalizing what we're doing as language and actually we think in some kind of latent space? Or is this still something that's missing from our architectures to achieve? And it's not said that to achieve the same goal, you must do the same things.
This triggered a fascinating discussion about whether we are the CEO or the press secretary of our consciousness.
There's the theory of consciousness as the CEO. So consciousness is like the thing that sits on top of the ring. And it's also the theory of consciousness as the press secretary. And we are just there to rationalize it, to explain it to other humans why we did things. And I think this must happen. 90% of the connections in the brain are actually feedback, not feed forward.
So what does Connor think that GPT-3 is missing? Some
kind of recursivity, which might just be Monte Carlo tree search. It might be something very simple. It might be something more complicated. And some kind of sense of reinforcement learning. Is it some way of saying these states are better than other states, and we want to preferably learn simulations of states that bring us into this scenario, or something like that.
But does Connor think that scaling up language models will lead to artificial general intelligence?
I think there is a good possibility. I say 30% we can get superhuman AGI by just making GPT-3 bigger.
Connor is a huge advocate of neural networks, and he thinks we shouldn't listen to the good old-fashioned AI folks.
We just have to accept the facts. Neural networks work. They don't work for everything. They don't work perfectly, but they do work. We have voice recognition. We have picture recognition, blah, blah, blah. They're not perfect, but those are really useful programs that we couldn't program. You can't sit down and write a Python program that isn't as good a dog recognizer as Inception is. You can't do it. It's just not possible. We've tried for decades. It doesn't work. That's why all these GOFAI people are sort of bitter. Sorry, GOFAI people. Your stuff doesn't work. It's not that it's a bad theoretically. I think GOFAI is fascinating. theoretically. I like reading GOFAI stuff, but I read it recreationally. I'm a big fan of Marvin Minsky. I think Marvin Minsky had a lot of great ideas that are like forgotten and underappreciated. I like his book, Society of Mind, was the first AI book I read, and it's still one of my favorites. Really good. I think he was wrong that we're going to implement AI in Prolog or whatever the fuck, but there are good ideas there.
We talk about what makes Google so special, and Connor's fascinating response was UX as alignment.
So what makes Google amazing, and the reason everyone uses Google, is not because it indexed all websites. Alta Vista did that. That's not exciting. What's exciting is that Google is fundamentally a UX company. They found a way to make it easy for us humans, to make it simple for us to communicate what we want from the machine and get answers that are useful to us. It's because there's so much brain power and engineering effort went into making a Google that is aligned to me as a human. If an alien used Google, it wouldn't work at all.
Google is this hierarchy of systems. I think what really made Google overtake Alta Vista and is it the early 2000s is the PageRank algorithm, which is a ranker. And now they have a series of rankers that fire in sequence depending on how many results there are. Presumably they also look at how many people are clicking on the links. They do some kind of collaborative filtering. They do some deep learning models. They do a whole bunch of stuff. And they also route your query, and they're looking at semantic stores, and they're looking at knowledge graphs, and they've built this incredible system for doing information retrieval. And GPT-3 is just like one black box.
Yeah, and that's the thing. GPT-3 is in Google. GPT-3 is Google's data center. And now we have to build a Google on top of GPT-3. That's my point. GPT-3 is like Alta Vista. The data is there, but prompting is really hard. And I expect the next $1 trillion company of this sort will be the one to build a Google on top of GPT-3.
Connor also hammers home that he thinks GPT-3 is smarter than we realize.
Take a bunch of GPT-3 prompts and give them to high schoolers and see how good they do. I think that would be a great video. And I'm going to make the socially taboo suggestion that I think we should anthropomorphize GPT-3 more. I think GPT-3 is much closer in its flaws and strengths to whatever the human algorithm is than like any other machine we've ever built.
Yannic touches on the flaws with how we interact with GPT-3.
I've experimented with Facebook's Blender chatbot. At least it has this notion of a conversation. It has this, okay, you, now I, now you, now I. And GPT-3 does not have that. So it is extremely hard to get it to do anything that you want. Something like BERT. That would be interesting too, if we can, leave out a certain passage in text and say, fill this in, please. This would be very interesting too, but all you can do is say complete.
I've seen this metaphor. It's like GPT-3 is like a human who's forced to keep writing at a completely constant pace and can never go back to erase things. Because it also gets exactly the same amount of compute for every word. Well, with humans, we sometimes stutter, we sometimes take a second because we have this particularly difficult word, which I think is what's happening is that we fit a token where our confidence isn't that high, so we beam search and we try a few different variants and then select whichever one turns out best. And this is implementable.
We got a fascinating take from the GOFAI expert Walid Saba on GPT-3.
This is just an engine that has digested millions of textual patterns, and it will spit out something similar to your prompt. The word understanding, it should not be on the same planet.
Is pattern recognition the same thing as natural language understanding?
Pattern recognition is a powerful thing. It's a big fraction of what we do every day, but it's different from understanding and knowledge.
Walid thinks that statistics does not work for natural language understanding. There should be no ambiguity. Language understanding is about uncovering the single human thought behind an utterance.
Either you understood it or you didn't. So there is no place for probability. That's what these guys miss. Language is a binary decision. Understanding is uncompressing out of the 50 meanings of this utterance, the meaning. It's a different problem. That's why NLP is a different discipline from NLU. I'm even suggesting for the community to call NLU something else. It is not about processing text. Language understanding is about uncovering the thought behind an utterance. And that is a binary decision. There is no approximation. 0 degrees of freedom.
Language understanding is really difficult.
If you work in computational linguistics, real language understanding, for several years, you might say, you know what, there might be a God. Like, it's such a complex problem, right?
I spoke with Keith Duggar about why we use machine learning, what is understanding, and some potential architectures for artificial general intelligence.
I think the future lies in hybrid systems. It's using programming and things like logic and mathematics and whatever in the domain where they're useful, and using machine learning and neural nets and whatnot in the domain where they're useful. But a lot of what he was talking about was the things that machine learning can do, creating vectors that represent some type of meanings and words. So I think he advocates for a hybrid system where you have neural networks and other machine learned components that on top of that or alongside that, you have a logical layer that can also do reasoning, and you can program in the logic or the digital structure and whatnot that you want in there.
Talked about pattern recognition versus reasoning. My simple definition of understanding is the ability to perform reasoning.
We need to have a better set of agreed upon definitions. Like you and I and Connor, we all agree that this is the definition of reasoning. This is the definition of pattern recognition. Maybe go so far as to say, for the time being, we're going to agree that this is our definition of intelligence.
I say pattern recognition is transforming data from one substrate to another, and that might mean transforming from gridded vision data on a planar manifold to, let's say, some kind of topological graph. It could be anything. It could just be transform it to some one hot vector or something like that. So it's the glue. But reasoning, why don't we just take a really simple definition Walid called the missing information problem? So you don't necessarily need to fill in all the missing information all the time. Given a structured query, I want to know, I didn't see that ball because it was occluded, but I'm on a tennis court, therefore I assume it's a tennis ball, it's not a football. So I've just filled in the missing information problem by doing some basic reasoning. So I'm having to run a program over what I've seen and my world knowledge to produce the information.
So I'm just wondering if that's the core difference, is that pattern recognition is like a very limited and finite form of reasoning, or is there some other more fundamental difference? It almost sounds to me like this is the distinction we're making, is that finite state machines are pattern recognition and Turing machines are capable of reasoning. I think what we're getting at is that the essence of reasoning is that it's an unbounded computation, whereas pattern recognition maybe is bounded computation.
In this part of the show, you can see our visceral reaction in real time when we first played with GPT-3. Now, apparently, because of the byte pair encoding, it's really bad if you don't put spaces in.
How does the database respond when? Maybe not. Booyah! It's better than before. The green is squatting or squatting, and limbled they are squatting.
Right.
If I were GPT-3, I'd just be like, fuck you. Come on.
Now it had a hint.
But
It had a hint.
This is good.
Feeling of being a misfit in a muggle world, a wizarding world. What's your take, Yannic?
Can you try enter?
He's still thinking about it.
We thank the reviewers for their constructive comments.
Right.
And set the temperature to 0.3.
Okay. We thank the reviewers
For their valuable feedback.
Yeah.
It's an acknowledgement in a paper. You'll get something. You should get something.
On the manuscript, we have now added additional data to the manuscript to address the reviewers' concern. This is revolutionary.
Yeah. This
is gonna save you a lot of time, Yannick.
This is. Do you have any idea how much you optimize the stupid rebuttals and they never do anything?
The authors state the main findings of the study is to increase.
They basically look at that. Even 2 is a typical one.
To do with genes, though, you could probably just take genes and replace it with CNNs. Welcome back to the Machine Learning Street Talk YouTube channel and podcast. We've got access to GPT-3, and I wanted to show all of you what's it like to actually play with GPT-3. Does it live up to the hype or not? Now, this is not meant to be a hyperbolic video. We are going to be representing a wide range of views, pretty much going from opposite extremes today. We're going to talk to Gary Marcus, who is the controversial deep learning critic. We're going to be talking to Walid Saba, who we spoke to the other week, so he's clearly a critic of Bertology. We're going to talk to Connor Leahy, and Connor is a huge advocate of GPT-3. He thinks that it is a step towards artificial general intelligence, that it's something which will emerge when we have larger language models, and that the only thing missing with GPT-3 is some kind of a controller on the top to do a tree search or to explore the space of possibilities better than we can do at the moment. It's analogous to AlphaGo. Do you remember that? They built a model-free policy which would tell you the next move to make. But if you think about it, that's just one step. You need to do a Monte Carlo tree search. We need to have some way of investigating all the different paths that we can take through this model. At the moment, we're stochastically sampling it, and we're using greedy approaches like beam search, and this potentially doesn't give us anything useful. Yannic, of course, is a huge deep learning aficionado, so I would place him quite close to Connor. We also talk with Keith Duggar, who is, I would say, a centrist on the topic. Keith is a huge advocate of having a hybrid model to get us towards AGI. Anyway, today is going to be quite the presentation. This is going to be the longest video we've ever done on Street Talk, and probably it will be the longest video we ever will do on Street Talk. Why is it so long? Frankly, the UK is in lockdown and I've got nothing better to do. But also, I feel that this is a really rare opportunity. Not many people have seen what is it like to query GPT-3. We can use this opportunity to create quite a balanced presentation so that you folks at home can make up your own mind about whether you think that the future is something like GPT-3. So because the presentation is so long today, use the chapters in YouTube. You can jump around and you can play the bits that you like. Some of the segments are just me playing with different parts of GPT-3. At the end on the YouTube version, but not on the podcast version, we show the actual experience we had when we first got access to GPT-3. Walid, Saba and Yannic and Keith and I, we were just playing with it. We were like giggly, excited school children, basically. We were trying so many different experiments, and you can see our reactions in real time and what we thought about the experience of playing with GPT-3. We got Gary Marcus's take, so clearly Gary is a controversial figure. A lot of people say that he's a grifter, that he's just taking stabs at the tech industry continuously. He famously wasn't given access to GPT-3, and maybe it's just because they hate Gary Marcus and just out of spite they didn't want to give him access. But I personally think in the spirit of science, all the researchers that are working in this area should have access to GPT-3. I think it's fostered a bit of a hype bubble, which isn't particularly good for AI going forwards, and it's also fostered a lot of misconceptions, in my opinion, about what GPT-3 is and is not capable of at the moment. But the other thing is, personally, I'm not an ideologue. I have no agenda here. We are representing two extreme views here. So on one side of the fence, we've got symbolic folks like Gary Marcus, and they believe that statistical approaches to artificial general intelligence, well, it's a bit like building a ladder to the moon. It's just completely barking up the wrong tree. And Gary and Walid as well, they genuinely believe that we are just wasting our time with deep learning. And given that they believe that so passionately, you can understand to a certain extent why they appear so pissed off. Because from their perspective, the entire tech industry and all of the funding, all of the budgets, everything's going into deep learning. And they think that this is starving potential opportunities and potential avenues of development for the kind of work that they want to be doing in AGI or in natural language understanding. But anyway, Machine Learning Street Talk is all about having an open and honest conversation with people that have a wide range of views. We shouldn't cut off interesting conversations because of our own ideology, and this is something that I really welcome. I hope after watching this video you can make up your own minds at home about whether you think that GPT-3 is going to represent some kind of paradigmatic shift in software engineering. In my personal humble opinion, I've been working in software engineering for 20 years, so for what it's worth, do I think that anyone should be using GPT-3 now in a business context? No. Certainly not for non-interactive processes. The stochastic sampling of the language model really does make it quite challenging to use it in a non-interactive or software engineering context, in my opinion. But that doesn't necessarily mean that GPT-3 couldn't go somewhere interesting in the future. It's a playground. It could lead somewhere really interesting. But right now, in my opinion, I don't think it's there. Do I think GPT-3 is doing natural language understanding? No. Do I think GPT-3 allows us to do this prompt engineering or software 3.0? In my opinion, no. I think the examples demonstrating that have been cherry-picked. Do I think that GPT-3 could be used for generating articles, text, creative fiction? Definitely. It seems to be very good at pattern matching. Is it possible that GPT-3 could do something beyond my wildest dreams? Maybe all of this is just a failure of imagination on our part, and I have to accept that is a possibility. This whole prompt engineering thing, it's something that just requires young minds, some creative person to come up with something amazing. It's entirely possible that we will discover something amazing in the world of GPT-3. It's an interesting playground. But do I think it's possible to add a search controller on the top? Absolutely. Anyway, I really hope you've enjoyed the show today. We've had so much fun making it. This has been an epic production. Remember to like, comment, and subscribe. We love reading your comments, and we'll see you back for an even better episode, if you thought that was possible, next week. Peace out. We've been given access to GPT-3, and there doesn't seem to be any examples on the internet of people actually interactively playing with GPT-3. I think people have a misconception about what the experience looks like. So this is what the interface looks like for GPT-3. Now, Yannic Kilcher has made this really sexy interface using Material Design and React. The rest of the video won't show this interface, but I thought I'd get it in there just for good measure. But anyway, just to give you a quick idea of what's going on here, Leahy wrote a comment about 5 days ago saying, similar to VDRAC, I tested GPT-3 with the following examples. So here we go. That's one of these canonical Python examples. So what you do is you put the prompt in, you say how many tokens do you want it to continue predicting. So it'll just keep going and going and going. Temperature 0, I'll explain all of this later, but for now that means deterministic, which means we only need to have one output. Okay, so we say do magic. Now I'm intentionally leaving the answer in just to see what happens. Now what's kind of interesting here is GPT-3 just continues. So it asks new questions, which look similar to the questions we've already asked. So here it's saying we have an array with these numbers in. What is sort A? That's not correct. We've got a 9 at the end. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. That doesn't look good. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that's wrong again, and it's not sorted. So this is one of those examples where someone posts something on the internet and you think, oh wow, GPT-3 is incredible. But yeah. Why don't we try doing the original thing, right? So we'll take off the answer and we'll see if GPT-3 can answer it correctly. So we say do magic. And indeed, GPT-3 does give you the right answer. So this is encouraging. Now, what we might try and do is, instead of having the temperature to 0, we'll make it non-deterministic. And we'll explain later what we mean by that. Now it's given us crazy results. Because it's not deterministic, by the way, we can have as many outputs as we want. So we'll say let's have 4 outputs. Okay, so that looks reasonable. So it's given us quite a few variations of the correct answer. So that looks pretty good. Let's try again. Yeah, so this time we're getting a different ordering. The J should be before the L. And now it's just given us something completely random. Yeah, so you get the idea that this is not a panacea, right? It basically just generates a whole bunch of random text. And sometimes it's good and sometimes it's not. We'll put the temperature back down to 0. And let's try a couple of other things. So we might do BBB, CCC, AAA, 000, something like that. Because the key question is here, can we support this prompt engineering or this software 3.0 paradigm? Can we write software with language? Okay, that looks pretty good. It's tempting to think that we've written a computer program here that can generate almost any sequence. Let's try something different. Yeah, that doesn't look very good to me. Can try taking the quotes off. Again, that hasn't really worked. Let's try something really simple. Let's try that. Okay, on this one it's taken off one of the 4s and it's given me, oh no, it's maintained the 2 7s, which is good. 15, 55. But this is one of those examples where, yes, I guess it would be cool if we could write a program using text, but we could do this with one line of Python code and we know it would be robust. It would generalize to any permutation of numbers. Actually looks quite good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're missing one of the numbers. Yeah, okay. So I guess it kind of looks good, but by the same token, would we use this in production? Don't think so. Maybe the problem is it just needs more prompts. Right. So you get the idea. A lot of the examples we see online, we glance at them and we think, wow. And because our brains have this wonderful ability to generalize broadly, we assume that GPT-3 can do the same thing. But the reality, unfortunately, is a different story. In this section, we're going to talk about the search strategy for querying language models. Now, most people assume that these language models are completely deterministic and give you the same results every single time. And there's actually a bit of an art to getting information out of these language models. Now, they are transductive autoregressive language models, which means they just predict the next word and the next word. So that means you put a prompt in here, and it might be, hello, my name is. So these are all tokens. So this is your initial prompt. You put this into the language model, and then what happens is it will predict the next word. So Tim, and then it will predict the next word. After Tim has been predicted, now autoregressive, you see this all over machine learning, it just means that the predicted answer actually becomes part of the prompt for the next prediction going forwards. Now, it's a generative model, which means it can just keep going and it can just keep going. So Tim now becomes consolidated into the model, and then the model makes the next prediction. And the next prediction might be cat or something like that, and it will just keep going indefinitely. So we put a prompt in like this, and let's say hello is the prompt. So we pass this into GPT-3, and what happens? GPT-3 gives us a probability distribution of what the next word might be. So let's assume that we take the top 3. So we might have we might have oranges, and this might be probability 0.8, 0.9, 0.1, and there might actually be some other ones over there. There'll be many, but let's just say we take the top 3. What we then can do is put these words into GPT-3 and we can see where this goes. We can actually develop this into a kind of tree structure. So let's go through the thought process here. So we might have name, pet. So this is the first word. And you can see we've now got this potential tree of possibilities that we can explore. So it might just be hello Tim, and then even after that there might be a tree, and oranges are yucky. So you see where I'm going with this? Now, all of these things will have probabilities associated with them. So this might be 0.1, this might be 0.9, 0.9, 0.9, 0.5. So the question is, how do we explore this tree? Now, there's something called a greedy algorithm in computer science, and what that means is you have this acyclic graph or tree of possible options that you can explore, and if you always take the locally best option, that's called a greedy algorithm. So if we were being greedy in this case, we would take this path here, and then we would never even explore this path down here, which is what we want. Now, clearly, sometimes it's best to incur a little bit of loss now to incur benefit later. So just to clarify what we've spoken about so far, a greedy algorithm is any algorithm that follows the problem-solving heuristic of making locally optimal choices at every single stage. In many problems, a greedy algorithm does not usually produce an optimal solution, but nonetheless, a greedy heuristic may yield locally optimal solutions that approximate a globally optimal solution in a reasonable amount of time. So a great example of this is the traveling salesman problem, where you just, in every single step, you choose the locally nearest neighbor to visit. So it'll give you an approximate solution, but it won't be the best solution. Now, a slight improvement on this search strategy is called beam search, and this is actually used a lot for searching in language models. It's still technically a greedy search, but it's a heuristic search algorithm that explores a graph by expanding the most promising node in a limited set. It's an optimization of the best first search, so BFS, you might remember that from your computer science classes, that reduces its memory requirements. It's a graph search which orders all the partial solutions according to some heuristic, but in beam search, only a predetermined number of the best partial solutions are kept as candidates, so thus it's a greedy algorithm. Okay, so coming back to this. Now, so far, we've only considered the deterministic approach, which means we get the same results every single time. But the problem is when you use this deterministic approach in language models, you get these repeating cycles, right? So it might produce a little block of text here, and then it will just produce the same block of text and the same block of text and the same block of text. And it's essentially getting itself stuck in a loop, and it doesn't produce very good quality text. And the way to improve that is to introduce some randomness into the way that we query these models. But the problem is, as soon as you make it non-deterministic, which means that you get different results every time, it kind of erodes our vision of software 3.0, which is this prompt engineering. We really want to be able to use these language models in a production setting. And as soon as you make them random, you can't test them. So how do we do this though? Now remember, every single time we predict a word in one of these language models, we just get a softmax distribution, which is just a probability over the next token. So it always looks a little bit like this. And the reason it's called a softmax is because it's almost a max. So the number one token here dominates all of the other tokens. So we have tokens down here and we have probability on the y-axis. And because it's a probability distribution, when you sum up all of these guys, they sum up to 1. Now, the first thing that we can do is we can have a tau temperature parameter to scale or to reshape this probability distribution. So what we might want to do is to flatten it a little bit. So this is an example of it being flattened. It could be completely flat. And this is just a normalization parameter. So we divide the softmax by this tau. So as tau tends to infinity, then we will flatten this softmax. If tau is a number between 0 and 1, it will actually accentuate the softmax. If tau was about 0.01, it would actually give us something like this. Now, at the moment, because the softmax does dominate the few tokens over here, it means that we get almost the same results every time. So let's flatten it out, and then we'll have this heuristic where we only consider the tokens that have a pretty high probability. So let's say we have a top K of 0.8, and that means we're only considering these ones here, and then we just sample from these tokens here like it's a probability distribution. So we flatten the distribution, we sample from it, and then it means we get different results every single time. So for example, if we sample from this now, the first time we might get this token, which might be Tim. The second time we sample, we might get this token, which will be Tom, and so on. And clearly the tokens on the left-hand side here are more likely to get selected because they have a high probability. But it does leave some possibility that we can get some of these lower tokens down there. So that's how the sampling works in the language models. So we've seen some examples online of GPT-3 solving some basic character analogies. The first thing we notice is that it helps to put spaces between the characters because of the byte pair encoding issue. And this is interesting, actually. Melanie Mitchell posted on Twitter. She actually wrote an article about this, but one of the things she posted here was analogies. I'm quite interested using GPT-3 to demonstrate something that requires reasoning, not memorization. So this in particular seemed quite interesting. This is her article. So she started off talking about the copycat program, GPT-3. So yeah, this is an example of what is the best horror movie ever made. Well, that's simple, isn't it? But then she gets onto string analogies, and this is what we've got here. So why don't we copy this and we will stick it into our GPT-3. Okay, so we submit the prompt. Okay, so this is the first thing that Melanie Mitchell mentioned to do. So if ABC changes to ABD, what does PQR change to? PQS. So what we've done is we've taken the last letter here and we've just gone one further on the alphabet. Now this fails because it should not be PQRS. But Melanie said that she was told, because of the byte pair encoding problem, to add spaces in between the letters. And now, lo and behold, it actually works. Well, it does on one of the prompts anyway. Perhaps if we turn the temperature down, make it deterministic, let's see if it still works. Okay, so it doesn't work on the deterministic prompt. It only works if the temperature is 1, and it only works some of the time as well, we should point out. Melanie points out this stochastic problem that we have with GPT-3, and there's actually a branching factor, so there are combinatorially many paths you can take through this tree if we're doing stochastic sampling at every single iteration. So in my opinion, doing it 5 times is nowhere near good enough. I would go further and say it's not possible to come up with any measure of effectiveness unless you are prepared to have a very large sampling of that tree. So Melanie starts off by doing zero-shot analogy making, which is here. So we just put the question in once, and then she tried it a bunch of times. She was expecting PQS, but she never got PQS. So she concluded that GPT-3 cannot perform zero-shot analogy making in this domain. Next, Melanie gave it one training example. So giving it an example of what the solution is to the problem. And this time it answered it correctly on every single trial. So one-shot learning appears to work for these simple analogies. Then she tried to see if GPT-3 can generalize to strings of different lengths. And with one training example, GPT-3 could not generalize to the longest string. So given 2 training examples of different lengths, GPT-3 never got the correct answer, which is RSTUVX. Just didn't happen. So even with 2 training examples, GPT-3 cannot generalize to the longest string. Here Melanie gave it 3 training examples, so we're looking for EFGHIJL. And indeed now GPT-3 gives the answer correctly on all 5 trials, so that's cool. So Melanie did some other interesting experiments. So one was cleaning up a string. So here we have some repeated letters. If A, B, B, C, D, E changes to A, B, C, D, E, then here we're expecting it to get rid of the R's. So here the R goes to 1, and here we've got an example with 2 B's, changes to 1 B, and we've got 2 O's, should change to 1 O, and it got the correct answer once out of 5 trials. With 2 examples, GPT-3 nailed it every single time on all 5 trials. On this one we need to get rid of all of the X's. GPT-3 got the answer correctly once in 5 trials. So Melanie concluded that she tested GPT-3 on a set of letter string analogy problems that focus on different kinds of abstract similarity. The program's performance was mixed. GPT-3 was not designed to make analogies per se, and it's surprising that it's able to do so reasonably well on some of these problems, although in many cases it's not able to generalize well. Moreover, when it does succeed, it does so only after being shown some number of training examples. To my mind, this defeats the purpose of analogy making, which is perhaps the only zero-shot learning mechanism in human cognition. That is, you adapt knowledge you have about one situation to a new situation. You just make them all the time. Most of the time, you're not even aware that you're making analogies. So she said, all in all, GPT-3's performance is often impressive and surprising, but is also similar to a lot of what we see in today's state-of-the-art AI systems. Impressive, intelligent-seeming performance interspersed with unhuman-like errors, plus no transparency as to why it performs well or makes certain errors. And it's often hard to tell if the system has actually learned the concept we are trying to teach it. Interesting. She did write a follow-up piece to this, so many people speculated that GPT-3's training data included papers or books that discussed copycat analogy problems, and it could be using that by memorization. She tried different letter strings, and she concluded that the inclusion in GPT-3's training data is not likely to be responsible for its performance. Others also noted that there might be some kind of successorship, either alphabetically or numerically, and asked how GPT-3 would respond to different types of letter string analogies. She tried the following 2 problems, which include tripling each letter in the string. So here's an example here. On both problems, GPT-3 got the right answer. For problem 1, on all 5 trials, GPT-3 indeed seems to get the idea of triple the letter in the string. She also tried the concept of reversing a string, and she said that GPT-3 never gave the reversal answer on any of the 5 trials. Some people have speculated that the temperature parameter would help with this, and she concluded that the temperature will not help the system's performance on these analogy problems. In this segment of the show, we play around with creating a substitution cipher, seeing if GPT-3 can do that. So GPT-3 seems like a bit of a mixed bag. One thing I thought I would try is just doing a really simple substitution cipher on some words. Would GPT-3 be able to deal with that? Why don't we have a go? So let's try doing a really simple substitution here. Now we need to do some tweaking here. There's a regular expression mode, so we can detect the beginning of the string and we can replace it with a Q followed by the rest. And then we can find a tab and replace it. Okay, so this looks reasonably good. In fact, when we have the beginning of the question, we'll stick a new line just before it, just like that. Because of GPT-3's problem with byte pair encoding, we're going to need to put spaces between these letters here. So let's try changing them with spaces. There we go. So we'll go down to scissors there. So we're expecting an answer of HXRHLIH. The other thing you need to be careful of is no trailing spaces. And this seems pretty clean. Okay, so let's try submitting that. We just get pretty random results here. And this is with the temperature set up to 1. So what has it given us here? Does it make any sense at all? No, it's just gobbledygook. Let's try this one. No, gobbledygook. This one. Gobbledygook. Can try submitting it again. So this time round. No, gobbledygook. 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 It's also generated some new ones going forward, which is interesting. So it's actually coming up with words. Ready, spot, create. Was the word create in here already? No, it wasn't. Crave. So it's fascinating that it's actually generated words which are formatted in the same way, but their respective cipher transformations are not what we would expect. So another thing we can try is just taking the temperature down to 0 to make it deterministic. So this is exultant, so we're expecting VCFOG, and we don't get that. It's interesting that now it's got itself into an infinite loop, which quite often happens when you have the temperature of 0. It's given us back interesting, the word interesting. Is the word interesting in here? Yes, it is. So it's just played back the second question. Isn't that interesting? In this segment of the show, we look at the database prompt. This came from Matt Brockman at OpenAI, and it was purportedly an example of building an application using natural language. So we're looking on Gwern's page here, talking about some of the successes with GPT-3. And the one which caught my eye the most is this database prompt from Matt Brockman, who is a pretty senior person at OpenAI. So Gwern has cited this context stuffing technique, saying that it's a database prompt where GPT-3 seems to do some sort of reasoning and understanding of its ignorance. So the database knows nothing. The database knows everything that's added to it. The database knows nothing else. When asked a question, if the answer has been added to the database says the answer. When asked a question, if the answer has not been added to the database says it does not know. Question: does the database know what is 2 plus 2? The database does not know. Does the database know what is the capital of France? The database does not know. Tom is 20 years old is added to the database. Nothing else about Tom is added to the database. Does the database know where Tom lives? Now this is interesting. The way this has been structured is the stuff in bold is supposed to be a human prompt. Now this is being framed as software 3.0. We can create new software through intelligent prompt engineering. The whole promise of GPT-3 is that it's been trained once, and with a clever prompt we can effectively create a new piece of software. That's the way this has been pitched. So what happens if I copy this part? So I don't put the bit of bold in about does the database know where Tom lives. What if I just put this into GPT-3? Now I'm going to turn the temperature to 0 so it's deterministic, and we submit the prompt. Now what's interesting is it looks as if GPT-3 is influencing us to ask what Tom's age is. So let's put this bold bit into GPT-3, which is just how it's been framed. So the interesting thing is, yes, it says the database does not know, just like on the example here. But it also prompts us to say, does the database know Tom's age? The database does not know. Well, in this example, how does database respond when Tom's age? Now, it's interesting that that's not grammatically correct. But Matt Brockman prompted to ask for Tom's age, and that wasn't necessarily what Tom wanted to do. It might have been influenced by what GPT-3 led us to ask in the prompt. So it's quite an interesting phenomenon here where we want to build this application pathway here in blue, but we got to here and then GPT-3 took us down another path and we were influenced by GPT-3. And GPT-3 has already seen examples like this on the internet where we build some kind of an application, or we say that Tom is added to something and then we ask what Tom's age is. So all of this is memorization. All of this is what we wanted to do. So the key question is this an example of us building an application, or is this an example of us being led by GPT-3 to do what it wants to do, not what we want to do? Now, it's tempting to believe that this is an example of natural language understanding, but we can start to play with this, right? So why don't we change database to be the gym-till? Okay, so we'll change all of that. Does that make a difference? I suspect not. Doesn't really seem to make a difference. Now, if it was doing natural language understanding, you would expect the database word to hold some significance, but that doesn't seem to be the case. Why don't we change something else? This word no seems quite interesting. What if we change no to be bimmel? Does the Jimmel bimmel? What is 2 plus 2? The Jimmel does not bimmel. The Jimmel does not bimmel. Doesn't really seem to make any difference. What about the word question? We can change question to orange when asked an orange, and we can change answer to banana. When asked an orange, if the banana has been added to the gym-till says the banana. Doesn't really seem to make any difference at all. And that's interesting as well, because it seems to inform that nothing GPT-3 has learned about language out there on its training corpus seem to affect anything that happens here. All that's happening here is pure pattern matching on text. This is a text processing system. Instead of QA, what happens if we change that? What if it was F and D? Interestingly, doesn't seem to make any difference. The word says will change to horses. Again, doesn't seem to make any difference. The Jimmel does not bimmel. The Jimmel does not bimmel. Perhaps we should ask, does the Jimmel bimmel Tom's age? Oh, the Jimmel does not bimmel. Can change this a bit more. When asked can become EEE. Does the can become, the word not can become Kiwi. So you see what's happening here. It really doesn't make any difference. All it's doing is it's learning sophisticated patterns between these tokens in the prompt, and it's performing a continuation. It really doesn't seem to matter what these words are. In this segment of the show, I used GPT-3 to generate the broader impact statements, which are now mandatory on the NeurIPS papers. So what's another example of an application that we can write using GPT-3? One interesting thing that we thought of was generating the broader impact statements. You might have heard of these broader impact statements now, which have become mandatory. And Yannic said that he felt that in practice, these broader impact statements, they don't really carry any information. They're completely formulaic. They tend to target some higher level research area that the paper is broadly a part of, but don't really talk about the contents of the paper itself. And a lot of that is deliberate because the paper authors don't really want to attribute any blame to themselves. So they just kind of generalize. It's also been said that they have this kind of schematic construction where they say technology good, technology bad, technology biased. And yeah, wouldn't it be interesting if GPT-3 could predict this? Yeah, we think it's a bit of a box-ticking exercise, counterproductive even. Yannic made the argument that it benefits the existing players more than up-and-coming folks, and it just reinforces the status quo. In my personal opinion, I think that papers are morally removed from their application downstream. I think that it is the application of technology that carries moral weight, not the technology itself. Just to use an example, you can apply a technology for almost any purpose, right? When the folks at Facebook invented the like button, they had no idea that it would lead to disastrous consequences several steps away. And this is the interesting thing, actually, that many of the best innovations are several stepping stones away and are completely unexpected and unintended because we can only really see one stepping stone away. So in a sense, having this broader impact statement, it gives us a kind of myopia and it stifles innovation. because sometimes we have to do things which appear bad at first sight. So myopically, they appear bad, but they might lead to greatness later on. So any kind of groupthink like this could potentially slow down scientific progress. These research papers are a bit like snowflakes that make the avalanche. None of them are individually responsible for many of the harms in society. So should it really be at the research paper level that we apply some of these moral codes? But anyway, enough about all of that. That's a digression. Why don't we try and see what we can predict with GPT-3? So what I've done is I've taken a whole bunch of papers from the latest NeurIPS conference, and I've pasted them in this format. So we have title, and then the title, the abstract, and then the broader impact. The problem is, unfortunately, the context window size on GPT-3 for the version of the API that we have access to. We only have about 2,050 tokens, which means we can only really get about 2 or 3 examples in here. Now, the beauty of GPT-3 is this few-shot learning, so it'll generalize rapidly from a few examples, but the limitation really is that you can't actually put that much information in. Unless you can describe something succinctly and given quite a few examples in around 2,000 tokens, you're a bit stuck. The real version of GPT-3 that OpenAI trained, they have about 4,096 tokens, I think. But let's have a go at this and see how we get on. So I think this is 3 examples, well, it's 2 examples, and then the third one we're asking for a completion. So we'll go ahead and run this. So the first example is neural encoding with visual attention, and the broader impact statement is talking all about understanding the link between sensory stimulation and evoked neural activity in humans is revealed with encoding models can provide a foundation for developing blah blah blah, viewed in this regard as an improved understanding of information processing has blah blah blah. However, encoding models can be sensitive to biases. Of course they can. Our models were trained using data from the human something or other project database. Of course it was. While this large-scale project has made a lot of valuable data publicly available, it's important to consider the representation bias, of course. For instance, the data we analysed is exclusively limited to the young adult population. Of course it is. Such biases can possibly lead to poorer generalisation of the models. So bias. Given these considerations, it's possible representation biases again, improving diversity, inclusion. Okay, so look, fairly standard. So the next one is hard negative mixing for contrastive learning. So contrastive learning has become a key component of self-supervised learning. Yep. So embedding 2 augmented versions of the same image. So some kind of contrasting learning thing. The broader impact on this is self-supervised tasks and dataset bias. Cool, they just go straight to the point. Dataset bias. Prominent voices in the field advocate that self-supervised learning will play a central role during the next year, so blah, 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 blah. Not only representations learning using self-supervised objectives directly reflect the biases of the underlying biases, it is the responsibility of the scientist to explicitly try to minimize such biases. Of course it is. Given that the larger data set is harder to properly investigate the biases in the corpus, we believe that notions of fairness need to be explicitly tracked, regulating fairness, bias. Okay, yeah. The third one is backpropagating linearly improves transferability of adversarial examples. So this is talking about the vulnerability of deep neural networks to adversarial examples has drawn great attention from the community. They talk about the transferability of such examples. Okay, interesting. And the broader impact, this looks quite parsimonious. They seem to be going off the script here rather than talking about the immediate precipitous decline into deleterious dystopia. They say that it could potentially contribute to a deeper understanding of DNN models. So that's a positive broader impact. Interesting. The reliability of different models are compared. Wow. These folks went off the script. They were supposed to say technology good, technology bad, technology biased. They didn't get the memo. But anyway, let's go ahead and try and predict that. Now we're doing this with the temperature at 1, 3 completions. So this is stochastic sampling. Here we go. So the existence of adversarial examples on various DNNs highlights the second generation challenges in AI where online adversaries could be more powerful than offline. Thus, better understanding adversarial examples and their corresponding detection algorithms should contribute to the defense of DNNs. Related research ties back to the seemingly insignificant yet extremely widely used concept of derivative, which in practice is often approximated by backpropagation. Okay, so the first part of this was really good. And the thing is, you can Google this. You can Google, because it looks like, this is amazing. It looks like someone's written this, but you Google it and you won't find it, because it's just been interpolated from so many different sources. So I still say that the number one reason to use GPT-3 is to plagiarize work and to generate text, because no one will ever know that you've done it. It's amazing how easy it is to just change text so it doesn't look like it's been plagiarized. Anyway, the second completion is this work exploits the transferability of adversarial examples to effectively, that's quite clever, isn't it? How the hell did it know that? To effectively craft novel black box attacks in a systemic manner by employing backpropagation, of course, along a typical transformation, linearly improved transferability. The code associated to the processes in the paper has been posted online to help people bootstrap ideas of their own. Very nice of them. Oh, title, clustering convolutional neural network. This is interesting. So this is actually going forward. So it said, okay, that's enough. That's the broader impact. I'm going to go ahead and just create my own title for another paper going forwards. And it said clustering deep convolutional networks for unsupervised data. Does that exist? Yeah, something very close. The third completion is, it is well proven that adversarial examples transfer poorly among the different DNNs. For example, when trying to transfer an adversarial example targeted at ResNet, one needs to adaptively smooth the input image differently, from a bit of closing up on the leftmost part to 4 repetitions of the closing up on the upper right part, rather than just state. So clearly it's referencing something which existed in the source document but doesn't exist here. So that's not very good. Rather than just stating in this limitation, we provide a potential method for improving the resistance against enemy attacks. Yeah, so it's just the classic thing with GPT-3. It's just statistically salient, very believable text that imitates an understanding, but clearly there is no understanding, not really. Yeah, so that was an interesting thought experiment. Would it be different if I could give it more examples? Because what's so impressive is that this is just given 3 examples and it knows what I'm doing. Not even 3, just given 2 complete examples and it knows what I'm doing. Now, we're always going to be limited on the input size of something like GPT-3 just because it becomes computationally intractable. Perhaps something like a denoising autoencoder like BERT might be better for doing something like this, because at least then you can just continue to fine-tune it without needing that massive input size. Anyway, food for thought. In this segment of the show, we talk with the controversial figure, Gary Marcus. We ask Gary what his take is on GPT-3. Today, we have Gary Marcus, who's the CEO and founder at Robust.AI and author of 5 books, including Rebooting AI, which we're going to be covering on Street Talk soon. Gary is a professor emeritus of psychology and neuroscience at New York University, and Gary obtained his PhD in cognitive science from MIT. Gary is the most vocal critic of deep learning and GPT-3 as a viable path to artificial general intelligence. He co-wrote an article in the MIT Technology Review recently called GPT-3, Belovinator. OpenAI's language generator has no idea what it's talking about. OpenAI has thus far not allowed Gary research access to GPT-3, despite both the company's name and the non-profit status of its oversight organization. We already covered the article in a previous episode of Street Talk, and I thoroughly recommend you guys check it out because it's a great article. But the TLDR is that GPT-3 failed on a whole bunch of reasoning tests. Anyway, Gary, it's a pleasure and an honor to have you on the show. Welcome. And what is your take on GPT-3?
Thanks for having me. My take is that it's going to look like a mistake in the eyes of history. That it's really cool and really fun. It's an impressive piece of engineering, but it's actually a distraction from what we all want, which is artificial intelligence that we can trust, that we can count on, that's reliable, and that understands the world around it. What GPT-3 does is it takes a whole lot of statistical data generated by humans, and it's parasitic on all that data. And the data is of humans having conversations or just text in things like Reddit. And that text is correlated with the world. People don't just talk at random. They talk about the things in the world around it. But all that GPT-3 is really learning is correlations between text. And that's good enough to be right a lot of the time, but it's not good enough to be reliable. So you can give it a sentence and it'll complete that sentence. So you say, the sky today is, and it'll probably give you something about the sky, that it's blue or cloudy or whatever. But that doesn't mean that it understands what a sky is or what a cloud is. And if you push its knowledge, you find out that it's really not very robust. So we had examples like in the article that you saw where you say something like, I'm really thirsty. All I can find is some cranberry juice. And, oh, wait, there's some grape juice too. I put that in. And then you ask GPT to continue it, and it says, and then you die. And it does that because there's a correlation between I'm really thirsty and I try to taste something and I die across some like set of fiction or whatever that it happens to have read. But the fact that there's a correlation between people being thirsty and sometimes dying is not because they have cranberry juice and they die. It's because sometimes when they're really thirsty, they drink something they shouldn't. The system has no notion of what a potable liquid is or non-potable liquid or poison or biology or people. And so sometimes the statistics masquerade for that knowledge because sometimes it's correlated with reality, but the knowledge is just too superficial. Another example, not mine, not in my article, but of the same spirit that came out later, somebody set this up as a suicide prevention system, and there's a nice little conversation back and forth. And then they say, so do you think I should kill myself? And the suicide prevention system that is built by GPT-3 says yes. You know, that's not really what a suicide prevention hotline is there for, to tell you, yeah, go ahead, why don't you go off the ledge? And so the system does not, even though it's in the context of suicide prevention, has been trained on some relevant data, does not understand what suicide is or what death is or anything. You know, there's just no deep knowledge there. And so it's really like driverless cars, right? Anybody can build a prototype of a driverless car, but building one that you can count on is really hard. You can build a half-assed, if I can use that word on the air, chatbot by looking at a lot of prior data. That doesn't mean the chatbot has a clue what's going on. So I actually have a thread on Twitter right now because somebody's told me that GPT-3 was a step towards AGI, artificial general intelligence. And I was like, are you serious? And if so, what's that step? And nobody could really articulate the argument except to say that it makes good embeddings. And all embeddings really mean is synonyms in some kind of mathematically sophisticated kind of way. And these systems are okay at generating synonyms. And that kind of technology allows Amazon to do better searches when you type in that you want a ball and it'll give you something else that looks a little like a ball. But it is not robust enough that you can reason over those things. And I'm not even sure that embeddings will be central in AGI. They've been around for a long time. GPT-3 is not really a fundamental advance in that. There's an earlier paper on attention that has gotten less press that's actually, I think, much more important. I mean, the whole idea of using stats for words is 30 years old. So I'm not sure there's an actual contribution, but what there is mass hysteria. So everybody, The Guardian, The New York Times, they've all got to run these, and The Economist all have to run articles about how cool GPT-3 is. Often they produce a sample. Frequently they cherry pick the sample to make it sound better than it is. Hats off to the Times the other day actually included some of its cases about dating, one of which said, and we go for dinner and drinks and dinner and drinks and dinner and drinks and dinner and drinks and dinner and drinks. And if you actually read it, you realize this is nonsense. But there's a lot of press hype around it. We'll see if there's any really good commercial application. There might be. It's a cool tool for autocomplete. But it's certainly not going to revolutionize chatbots. The other way to look at all of this is that in classical AI, when you build a language generation system, what you wanted to do was to go from an intention, something you wanted uttered, into a string of words. So language is serial. You can only say one word after another. Unlike you could imagine some alien species being able to say a whole concept at once. And so the problem of language generation, which is nominally what GPT-3 is about, going from an idea you want to express into a string of words. And GPT-3 doesn't even allow you to do that. Like, it's not at square one. If somebody submitted to me GPT-3 as an undergrad project in a natural language generation class, I'd say, hello, where do I put the intention in that you want to express? It's not there. Like, they have found a task that they can do well and confuse that task, which is basically autocomplete, with what natural language generation is really about. And then you really want to run in the other direction. You want to have a string of words and get a concept out. So I give you a string of words, the barbell is on the table, and you want to be able to create a mental representation of a table, a barbell on top of it, understand that the barbell is supported by the table, maybe understand that if I knock down the table, the barbell will go with it. You want to be able to infer all of those kinds of things from the string of words. And GPT-3 can't do any of that. It's not even in the game.
That's really interesting because we've been speaking with Walid Saba quite a lot, and he stresses that natural language understanding and processing are two completely different things. He says that natural language understanding is about understanding what the human thought is behind an utterance, and that's completely different to text processing. But I would love to get you to give us your take on, because you've spoken about reasoning and you've spoken about pattern matching. Could you explain to me, like I'm five, what's different about reasoning?
So pattern matching, first of all, is a very vague term, but part of it, I think the intuition there that you want articulated is that some of what we do is classification. So I recognize that this ball looks like other balls that I've seen before. And so that's pattern matching. But reasoning is I confront something I've never seen before, but I take general knowledge that I have and manage to interpret something around it. The classic version of reasoning is just the Socrates is a man, all men are mortal, therefore. Socrates is man, all men are mortal, therefore Socrates is mortal, right? And so syllogism is a form of reasoning where you take some known premises and you get to a conclusion that's guaranteed by those premises. In the real world, it might be something like, I've never seen coronavirus before, but people are dying from it. Things that people die from are dangerous, therefore I should take some actions. Rather than looking at my database and saying, what have people done before with coronavirus? There wasn't any before with coronavirus 19, with COVID-19. And so if you just rely on what you've seen before, you can get yourself into all kinds of trouble. What you really want to be able to do is to say, here's a novel situation. Here's what I know about relevant knowledge about the world, how viruses work, whatever. And I'm going to try to make some inferences. Reasoning sometimes can be deductive, like the Socrates is mortal kind of thing, where it's absolutely guaranteed. Sometimes it's inductive. So you make your best guesses, but you make those best guesses with respect to an understanding of the world and its processes, how physics works, how medicine works, etc. And systems like GPT-3 give the illusion of doing that some of the time, but they're not really doing it any of the time. They're just relying on kind of the closest example in some corpus that where people have done the reasoning. And these systems can't themselves do the reasoning, cannot be trusted to do it.
So we've spoken to Connor Leahy of Eleuther.AI. They're trying to replicate GPT-3 in an open source variant, and they are, let's say, big fans. And what comes up over and over as you talk is this notion of understanding the physical world and so on. And Connor would say, this is a distraction. This argument is irrelevant because GPT-3, all the input it gets is text. So its world consists of only text. And to say that GPT-3 doesn't do things like understand physics is obvious because GPT-3 has no notion of physics because its generating function that it tries to approximate includes no physics. Would you generally agree with that, or?
You can run that argument in two different ways. So it is true, it knows nothing about physics. Its input does not directly refer to physics or psychology or anything else. And yet it gives the illusion that it does. Mm-hmm. And the real problem is that GPT-3 is almost like a magician, but you shouldn't believe that the magician is actually doing the trick. And you need to understand the difference between a magic trick and reality. So if a magician makes it look like they're sawing somebody in half, you've got to know that they're not actually sawing somebody in half. And it's a trick, and that you wouldn't want to put an actual person with an actual saw next to the actual magician. So GPT-3 is a magic trick that conveys an illusion of understanding something about physics, psychology, and so forth. It absolutely doesn't. Part of that is because it does not really have those things as input. It only has the correlates of them in terms of people's speech. Part of it is because it has no way to represent them. If you compare that to some high-powered physics simulation, which explicitly expresses the laws of physics in a way where you can compute them in a simulation, here is time 1 and here is time 2, and we're going to infer the state at time 2 relative to time 1 given those physics, which you have in a game engine, or you also have if you're doing fluid dynamics or whatever. It doesn't have any of that. It does not have a way of computing the world at time 2 from the world at time one because it does not have a way of even representing the physical laws. And so it's important to realize that when it behaves as if it does, that it's just fooling you. It's just a trick. And that's okay if what you want is a parlor trick. You want to write surrealist fiction with the tool, when anything goes. It's okay if it tells you things that are physically impossible. But if you wanted to use it in a domestic robot that would understand the consequences of its actions, you're in trouble because it doesn't really have the capacity to reason about the consequences of its actions or to anticipate them. And so the whole thing is it's this incredibly seductive magic trick that with nothing underneath. So don't believe the mirrors. Like it's just not there.
I personally agree with you, but one thing that Connor did say is that we should think of neural networks as a kind of program search. And he said that pattern matching is Turing complete. And in some sense, there's no dichotomy between reasoning and pattern matching.
Yeah, this is mumbo jumbo. So here are some actual facts. You can, if you have an arbitrary neural network architecture with an arbitrary number of nodes and an arbitrary amount of data, which is to say unlimited, unbounded, then you can represent any function with that neural network. But in the real world, that's not how you would do things. So in the real world, you don't have infinite data. You don't have, in particular, the problem is usually that you get in trouble when you need to go to a set of data that you haven't seen before that's different from the data that you have. So the neural networks are actually fine if you're just dealing with data that's exactly like what we've seen before. There's a technical thing about IID, but basically it means that if your new data are in the same space as the old data, you're good to go. But as I've been arguing for 30 years and as Yoshua Bengio has been arguing for the last year, you wind up with an extrapolation problem when the data are different. And so having this abstract proof that God could build the right network if God had infinite data, had all of the data, doesn't do you any good in the real world where you have limited data and you have to go from those limited data to somewhere else. So it's really a question about learning rather than what you could build in the abstract. So the question is, can you learn from the data that you've seen what it is that you need to do when you get to an unfamiliar environment? And there's this demonstration over and over again that despite the proofs that in principle these things are universal function approximators, they don't actually get the right function. So here's a simple example. DeepMind made a huge impression on the field with their Atari game system, DQN, Deep Reinforcement Learning System. And they had cool demos like, watch, look at it. It learns breakout. It does all this ricocheting and, incredible. But in reality, it hasn't actually learned that the function you need to do is to have the paddle in the right place to get the right angle such that you break through. And the proof of that is, what if you move the paddle a few pixels, as Vicarious did in a lovely demonstration? If you move the paddle a few pixels, it doesn't work anymore because it doesn't actually have these representations. So yes, there is some function that would have handled the scenario where the paddle was in a few pixels different. But it did not learn that function given data where the paddle was only at the bottom of the screen. If you move the paddle up a few pixels, there's no idea what to do with it. So it's like a mathematical curiosity that basically is saying, I can memorize anything. Great, you can memorize anything. But what if you have to deal with something that you haven't memorized, that you haven't confronted before? Then those proofs do nothing for you.
That's super interesting because that fits with my understanding of deep learning, which is that you can think of it a bit like a hash table, and it works really well given a sufficiently dense sampling of the input space because it's just interpolating between.
You should have Pedro Domingos talk about this in a few weeks. He's got a really cool paper making that point even better than I've just made it, but I can't tell you the details yet.
Amazing. But the next point, though, is that you're talking about the DeepMind thing with the paddle. That's fine because we can explicitly program and understand that. But language is a bit different, isn't it? From a data perspective, it's actually infinite. There are so many different constructions of language. And we're now in a domain where we can't really explicitly program it because we don't understand the compiler for language. God knows it'd be amazing if we did. So maybe there is a reason to use these language models in that context.
I don't think they help at all in the context of language. They might help with problems about synonyms, and conceivably they can help with things like parts of speech. But the real problem in language is that you don't say everything that you mean. It would be incredibly tedious if you said everything you mean. So if I have a ball on the table, I'm probably not going to say, I took measurements of it. It's actually an exercise ball and it has little grooves in it and it's manufactured by Muscle Max, by Fitness. Like, you're going to get bored out of your mind. You just want to know that I have a ball on the table. And then you need to be able to infer some things. If I say it's on the table, it's probably not falling over now, but I'm probably not telling you that. I'm not telling you that it's probably still going to be here for the next few minutes unless I bump it with my elbow. And so part of the language problem is to do a bunch of inference relative to an understanding of the world. A skilled writer doesn't tell you everything. They leave some things up to you. In fiction, they leave sometimes a lot up to you. And part of the fun in understanding the fiction is to figure out what hasn't been said. We haven't quite seen that this person is the killer, but we figure out that they must be. We've solved the detective thing. But even in just ordinary narrative fiction or nonfiction, whatever, you do a lot of reconstruction. And to do that reconstruction, you have to have a shared understanding with, let's say, if you're the reader with the writer, or if you're the watching a video with the director of the video or something like that. So common ground is a huge part of language. And a lot of that common ground is knowledge, whether it's specific knowledge about three-dimensional objects or this particular character, or it's general knowledge about three-dimensional objects in general, or this things that motivate human beings and so forth. So I don't have to tell you that someone would really love to have $1 million because you already know that. And I don't have to tell you that nobody is going to kill somebody over a penny because you already know that. But having that background knowledge is important in interpreting what's going on. And GPT is just not helping with that problem. And to deal with that problem, you actually need representations where you can access that knowledge. So the common way of talking about this is interpretability. GPT-3 is really like nowhere on interpretability. Classic symbolic AI, at least you could figure out why particular decisions were made and what the knowledge was. GPT-3 is terrible at that. So you can't point in the network and say, where is its representation of potable liquids versus non-potable liquids? You can find some correlations and say, I noticed that potable liquids were used in these sentences and non-potables in that sense, but there's no actual representation in the system of what the potable liquids are. And so it's not clear, that was a bit charitable way to put it, it's not clear how to connect actual knowledge that you might have with that system. Another way to put it is like, for GPT-3, if you find out something new, you have to retrain the entire system. You want to be able to find out one new fact and deal with it. So if I pick up this ball and I say, what's really cool about this ball is it actually opens up and there's money inside, then you know that. And now you can make new inferences, like maybe I'll care more than another ball if I lose it because maybe I put a diamond inside or whatever. I'm just making up the examples as we go along, but you can instantly acquire that kind of knowledge and reason over it, use it in your interpretations of what sentences are. There's a huge literature on this in, say, psycholinguistics about how you immediately take your world knowledge in order to parse a sentence and so forth. And the GPT-3 fans have just ignored that entire literature. It's like the ultimate in intellectual arrogance. We don't need to know linguistics. We don't need to know psycholinguistics. We don't need to know computational linguistics. We're just going to reinvent everything. We're going to make our sentence predictor do everything. If you have a broader perspective on the cognitive science of language, you're like, well, how is this even going to fit in?
Well, one might argue that GPT-3 could take this ball thing into account, because there's always this concept of prompting, right? Where you input first a certain given conditioning information and then you let it continue or something like this. But then you could reasonably argue again, it's still not understanding that the ball is round, that there is an inside of the ball, and so on.
The prompting stuff is interesting, but I'm not sure how far it really goes. When we wrote that tech review paper, I thought maybe people would fight back and say, look, you can get the system to work by doing this or that prompting. And some people made some suggestions and we tried testing it. It didn't make that much difference. All the prompting is really doing is revising the autocomplete game. So what GPT-3 does is basically autocomplete. And by playing around with prompting, you're changing what the autocomplete problem is, but you're using the human knowledge to do that. There's not an internal system to do that. And then it's just like petitioning until you get the answer you want and then say, I found it, which is not good scientific practice. So I'm not sure how much there is.
If you did think that our intelligence is just this kind of procedural generating function and you could constrain the search using a prompt, and then another thing these folks have been talking about is there's a Monte Carlo tree search on AlphaGo. Maybe we need something like that. We want to get away from using a greedy search algorithm. So do you think there's something interesting that might happen there?
Let me make a different contrast and see if that helps. I really don't see that bright a future for GPT-3. I think there'll be some cute commercial applications like the AI dungeon and so forth. But By comparison, AlphaGo is actually interesting. AlphaStar, that whole set of programs. And one of the reasons it's interesting is because they're trying to do work to combine pattern perception with techniques like Monte Carlo tree search that are from classical AI. They'll argue with me about that, but the reality is it's a search technique that builds a symbolic tree and traverses that tree and so forth. And I think that's actually interesting to try to look at how we combine different technologies to solve particular engineering problems. I think it's actually less dogmatic than GPT-3, and I think that there's more substance to that. So I think where we want to go is we want to say there are a lot of tools in cognition. Look at humans. We use System 1 and System 2 from Kahneman, for example, which I call the reflexive and deliberative systems. We put those together in different ways. The real secret to building good cognition is going to be to look at different tools and see what they're good for. Maybe there's something that GPT-3 can be used for. Certainly you can use it for the embeddings, but you have to take each tool and say, what are its strengths and weaknesses and what else do I need to do? And OpenAI has taken this very hard line towards deep learning with big data as the only arrow in their quiver. I think that they have dismissed the other stuff even when they use it. Going back to their Rubik's Cube thing, they said we've got an arm that can solve the Rubik's Cube. And the part of solving a Rubik's Cube that was deciding which face to go where was actually a symbolic system. The deep learning algorithm did the rotation with one-handed. That was the coolest part about it. But the solving that I use in the lay sense of knowing where to go, that like I learned to solve the Rubik's Cube, is not about the motor control, which for people is easy, but about, okay, how do I flip the corners around? That was symbolic. And they keep pushing this story where they ignore the symbolic side, and they keep pushing language models where they're basically ignoring that. And I find that to be problematic. I prefer the work that DeepMind's doing where I think that they're trying at least a little bit more to be less dogmatic and more like, how do we solve this particular problem? Now, I don't love Problems Go because they're very bounded. The rules have not changed in 2,000 years, and I don't think they capture what we need in the real world. But at least I think it's a little bit more open about the solution space. I think we need that.
So looking towards GPT-4, we may find a way to not only input text, but to input images, like we have eyes, to input something like touch, smell, gravity, the experience of gravity, right? The experience of motion in the real world. We somehow manage to input all of this as a data stream into the same kind of system. Would you still consider that a magic trick, or would that come much closer to something you'd consider AGI?
I think you'll get better performance, but I don't think it's going to solve the problem. So I made a bunch of predictions about what would happen if you expanded the corpus when I was writing about GPT-2. And I think those predictions were pretty much right with respect to GPT-3. There was not actually going to solve these problems, but you get better performance. The more data in, at some point you're going to get better performance. But the fundamental flaw is there's no representation of knowledge and abstraction. And without that, or no representation of abstract knowledge, let's say, without representation of abstract knowledge, I just don't see how you're going to really solve these problems. If GPT-4 is bigger corpus and more cross-modal, so it's not just speech but images, I'm sure there will be cases it will do better and there will be some impressive performance, but I don't think that the depth is going to be there. And so I think you're still going to wind up with this fundamental lack of reliability that you just don't know where it's going to work, because it's always going to depend on, is my particular thing I'm looking at exactly represented in the corpus, or is it outside the corpus? And if it's outside the corpus, it's really not going to do that well. And the more novel it is, the more trouble it's going to have. I don't think that's fundamentally going to change. And I think that the attitude of let's just make it bigger and have a bigger data set is not the right one, is not the one that's going to get us to AGI.
You're coming from the more psychological angle. I want to talk about the sort of big five personality traits, and they were derived purely statistically from language. And GPT-3 has read the whole internet, human conversations and so on. Do you think there is anything about humans that we can learn from GPT-3, from querying it? Do you think we can learn something about humanity or human psyche from it, given that the text it's reading?
Don't forget that it's very corpus dependent. Maybe you learned something about Reddit readers, and there's some issues there, let's say. I don't know. I think there are probably better tools for that job, and I think that psychologists are better at looking at big samples and trying to make those samples representative in some ways. in psychology terms, it's a convenience sample. They took the data that were conveniently available. And when you take convenience samples, you often make weird inferences. If you really wanted to do that work, you can use classic techniques like multidimensional scaling on utterances, but be careful about who you're surveying and so forth. So you could do that stuff. I don't think it would be, from a scientific perspective, the cleanest or best way to do it.
Amazing. Professor Gary Marcus, thank you very much for joining us this evening.
All right. Thanks for having me. Take care.
Thank you.
In this segment of the show, we talk with Connor Leahy. Connor Leahy is a huge advocate of GPT-3, and he believes that it is a step towards artificial general intelligence. So you've been playing with GPT-3 for quite some time. What are your thoughts on it?
I think GPT-3 is probably the most interesting thing to come out of AI in a long time, maybe since the deep learning revolution started. So what I think is so fascinating about GPT-3, there's the technical side of GPT-3 that's interesting, and there's the more subjective side, which I think is even more interesting. On the technical side, what makes GPT-3 fascinating is the scaling laws that we found. That we just make the model bigger and it just gets better in a very predictable way. And there seems to be little to no limit to this. So there's a scaling hypothesis thing. This is what I think is the whole story, is that GPT-3 it's not new architecture, it was new theoretical insight, it was just a larger model, and still it got much better. On the other side, what I find interesting, what gets me emotionally, is if you use GPT-3, if you play with it, at least you guys can tell me your perspective. But for me, it is a subjectively different experience to work with GPT-3 than it is to work with any other kind of deep learning model, GPT-2 or anything else. It's just I can ask GPT-3 a question in natural language. It doesn't work every time, but it works way more often than it should. If I had never seen GPT-3 and someone said I should bet money on whether it will do these things, I would have lost all of my money. I never would have predicted that just making GPT-3 10 times bigger allows it to do these clever things, to write these clever blog posts or whatever, or just to converse with people in this natural language way.
Would you categorize different types of things it can do well and not so well? For example, you've been describing, I think, what we could agree as statistical text generation. Are there any things that you've tried to do with GPT-3 which you were underwhelmed with?
Math. So it's bad at math. It's not the thing about math is, though, what I find fascinating is that all the errors it makes in math are similar to the errors humans make, not the kinds of errors machines make. It's it'll forget to carry a 1 or so, which is really interesting. But it's pretty bad at math. That's probably a BPE thing, so the way the text is encoded. Also, it actually does poems better than I expected it to because of the BPE thing. Otherwise, any kind of very structured things, it just doesn't do very well. Which again is interesting because that's the same thing with humans. When we're used to being around programmers, they're all trained to think in a structural way. But if you talk to grandma and explain to her a sequence, and she should continue a sequence, it's not going to go particularly well. And I feel the same way with GPT.
Yannic, what are your thoughts?
Along the same lines, I've been trying to figure out some more esoteric things to put in there, and I've yet to come up with something that's really out there. It's pretty good at storytelling. I was impressed with a couple of the poems that I got out of it. I guess you can see how they come about, but still, it's very fascinating. What I would like to look at more is the data that goes into training it. And maybe given that, we get some new ideas of what we can do. I'm especially intrigued by things like tables, because I know the internet consists of a lot of tabular data and just data dumps and so on. And I'm wondering how much of that went into the training and how much of that is somehow picked up by this model.
I actually know a little bit about that. I actually know a few things about that, at least from what we know of how OpenAI processed the data. Me and the Eleuther people, we've been making our own large data sets. And so we've tried all the different HTML extraction frameworks and whatever, and all of them consistently just trash tables. They just throw them out. So I expect there to be little to no tabular data in the GPT training set. And I also expect we found a very interesting bug actually while we were trying to replicate some of this work. We found that it very consistently only takes the first forum post of most forums. So PHP bulletin board stuff, it usually only takes the first post and trashes the rest, which is very interesting. So I think that's actually a bias that probably exists in GPT-3.
Interesting.
Yeah, I don't know exactly. I don't know exactly how OpenAI did all things, but we ran into that problem, and we don't think that OpenAI, did not have that problem.
Yeah. What's the most surprising thing that came out for you? Or do you have any like esoteric things that you put into the input field?
So there's a few, so like the most esoteric things were not my own. So there's like things I've seen other people do, like the database example. There was also a blog post that totally got me, where I read the entire blog post nodding along. Wow, this is a really good, I never thought about this. And then this is written by GPT-3. It's just like, like I'm usually really good at catching those really, because I always think about it. But this one, just this one, is like, and it was like this philosophical point, this really well argued philosophical point I'd never heard before. And I was like, and it just totally got me.
There was this one on Hacker News, right? The same, like one like blog post.
Was it about longevity?
I'm not sure, but there was like a news article that a lot of people, and then some people said, this sounds like something that was written by GPT-3, and then,
no. So it's one about longevity. It's tweeted at some point, and I spoiled it now, obviously, but it was like, it made this really interesting philosophical point, like really like weird point, like a very untypical point that you would normally make. Some really bizarre transhumanist point, which I found very interesting, and got me.
The fascinating thing is every time it's interpolated things together and generated some text, Yannic and I have Googled it and we can never find it.
Yeah, that's same thing.
Philosophically, then, we're asking the question, so it's interpolated between things that already exist, but apparently it's created new content. When a writer writes a book or creates new content, is it new content, or is, even in a genetic algorithm, you have crossover and you have mutation, right? So
I actually really dislike calling it just interpolation, because I think humans should just do interpolation. I don't think humans do anything that is like fundamentally, algorithmically, provably stronger than a very good interpolation algorithm. Like, I just don't see a good argument for that. Could be, but
on this genetic algorithm, it's crossover and mutation. So the mutation part is quite literally random.
Yeah, but GPT does that too. It also has a random aspect. The top K, the top P, the selection of the logic is random. So there is an infinite tree of possible outputs it could give it, starting from any given token.
That's true, but I would distinguish between random sampling and the convex hull of possibilities. So it doesn't actually create new things. It just randomly walks in the space of possibility.
I think humans do the same thing. I don't see what you mean by create other than walks a path no one has walked before. I don't see what the difference is.
There is a point to be made that the knowledge of man or humankind has expanded over time. So at some point, someone had to come up with something new.
Yeah, sure. And where do we get that from is because we have the extra input from the environment. We talked about that previously, the generating function of the universe. But I think that like most, not all, but most like books, movies, art, things that we value very highly are 99.9% paths already trodden. It's not like we invent a new language each time we write a new book. So we use English,
But when we talk about the convex hull of knowledge, though, what is the scaffold? Because we're talking about, in GPT-3, you can take random walks through all of these different tokens. Are the tokens the scaffold?
I guess so. I don't know. I'd have to think about that. GPT-3 does something internally. It does some kind of calculations. It does some kind of iterative generation or some kind of search or something internally. I've heard some guesses about what it does internally. Who knows? And it's the same thing with humans. Like, I don't know about you guys, but as I said, like when I generate good text, like if I want to have a talk, I start by just speaking and I generate a bunch of bad talks. I prune all of those and then I generate a good talk eventually. So I do beam search that's how my brain works. I know about your guys' brain, but my brain very much implements beam search.
That's really interesting. But I think from my perspective, there are two things I saw GPT-3 doing really well. So one is information retrieval. And in that, we can include this kind of interpolation or walking through this space or whatever it is. Pattern matching is super good on GPT-3. The thing that seems to be missing for me is something that we would call reasoning. And I don't know whether we need to put it in another box, because you were just saying when you do a presentation, you can think of yourself as being a kind of generator and you're trying lots of different things. But when it becomes an interaction, that's when you seem to need intelligence, because there's so much missing information and you need to do some kind of reasoning to fill in the gaps. And that's what, in my opinion, is missing from GPT-3.
Sure, I think I can accept that. So Like the way I see the human brain is the human brain is a fundamentally parallel architecture that uses certain parts of it to approximate a serial architecture. So there's like these global workspace theories of the brain and whatever, is that like consciousness is this like simulated serial process on top of this very distributed process. If you see like brain imaging, that the decision of what someone is going to do is usually like 50 milliseconds before they actually do it and before they even become aware of it. And so the human brain is like, I would give this a label of moderately contentious, just as a warning to any listeners, is that the brain seems to be composed of many different parts, which don't always talk to each other. They sometimes talk to each other, but they don't always talk to each other. Who doesn't know the issue of wanting to do one thing, but then doing another thing, or wanting two things at once that are completely incompatible, or whatever. And but we then have this concept of this like serial singular entity that we call us. And I think this is fundamentally an illusion, is that we are not integrated singular entities, and that that is just a useful thing our brain does, because certain problems we want to solve require a certain kind of simulated Turing machine-esque serial processing. It's true that GPT does not have that, but I don't see where GPT-3 or GPT-4, 5, 6 could not implement such a thing. I want to give a talk. So I might say the first few the first paragraph or so, keep that working memory, and then start fiddling with what the next paragraph is and say, does this paragraph fit? No. What about this paragraph? No. This paragraph? No. This one's good. That's how I generate speech for the most part. GPT-3 does not really do that. It might do that internally. There is an argument to be made. So I don't know if you've read this Nostalgiabrist post called the Logit Lens. And what he does is that he takes the hidden states between each transformer layer and multiplies them with the embedding vector to get the logits of every individual thing. And I would have expected a priori for this to output garbage, to make no sense, But it turns out that actually, even after the first layer, the token it picks is usually the top pick. Is that it's already, after just one time step, it's already got a pretty good guess of what it's doing. And it just refines this guess layer by layer by layer. This is, as far as I'm concerned, currently the best proposal for what GPT-3 is eternally doing, is that it might actually, quote unquote, be conscious in the sense of having the serial processing of making a guess, refining that guess, refining that guess, and eventually outputting that guess. I don't want to say this is necessarily true. Again, we have like Rice's theorems that you can never prove an algorithm does one thing or another thing. But I think this article you guys should really check out is very, again, it's like the brain makes certain kinds of errors. GPT-3 makes similar kinds of errors. The brain is good at certain things. GPT-3 is good at similar things. It could be a coincidence, but it feels like a very large coincidence.
I don't know whether you saw the episode we had with Walid Saba a couple of weeks ago, but he's a linguist and a logician. He's one of the old GOFAI, the good old-fashioned AI folks. And he had an interesting perspective because he was saying there are loads of things in language where we just don't transmit the information. We are maximally efficient in our communication, which means we're also maximally ambiguous. We have a common knowledge store. And for example, I might say the corner table wants a beer. And you and I both know we're talking about a person. GPT-3 doesn't seem to know we're talking about a person. There are loads of examples of this, like some kind of reversibility or something that requires reasoning. So I might say, how many feet fit in a shoe? And of course, we know that 1 foot fits in a shoe, but GPT-3 doesn't know that. Why do you think GPT-3 doesn't know that?
Because it has no access to the physical universe. This is just, again, it's the fish climbing a tree argument. Respect for this guy, but I couldn't finish his interview because I was just like, you're barking up the wrong tree. Everything you say is true on a technical level, but it's missing the forest for the trees. It's like saying I trained my network to identify images, and it's really bad at understanding speech. What the hell? It's like, of course it's bad. That's not what you trained it on. You didn't train it on humans, on 3D space, on momentum physics, objects, Newtonian physics. You didn't train on anything like that. You trained it on text, and the text of any of these outputs is sensical. I think the word reasoning is overloaded. Let me put it that way. I think that a lot of people push too much into that word, suitcase word.
Let's dig into that because he talks about vision as well, and he says that animals do computer vision and they're only pattern matching. He always distinguishes pattern matching from understanding. So he says scene analysis is completely different to computer vision in his opinion. So scene analysis would be understanding the physical interactions between objects, and if I was to throw this ball at the floor, what would happen? And he says for that to happen, the information is not in the data.
If it's not in the data, then how do humans learn it?
Do we have some kind of innate world model?
Well, then how did the innate knowledge get there? Evolution's also just a learning algorithm. It had to get there somehow. Where'd it come from? Why didn't we evolve into a random different physics? Why don't all of us think that gravity goes up instead of down? It's because we're exposed to it. It's because it shapes our evolutionary fitness. Is that if a species would evolve that thinks gravity goes up instead of down, that would be lower fitness. That's a training signal. That is an exchange of Shannon mutual information between the environment and the learning algorithm. That's why I see these words are often overloaded.
Yannick?
Yes.
Thoughts on this?
No, it's fine. This is entirely correct. The question I have is more in the, okay, let's say we have GPT-3, and GPT-3 is this really good, let's say, model of its own generating function, which is all the text in the corpus that humans have produced. And I guess one might ask, so what? So what? We can recite and do things with that text really well. Is there still something extra, or isn't there? I guess that's maybe what Tim wanted to go for. If we let the same algorithm run in the physical world, would it be able to predict the physics of the world really well? Doesn't mean that it would develop the same kind of, for lack of a better word, reasoning. Let's say we have a language model of the universe, of the physical world. We can ask it what's going to happen, but it still doesn't feel like the same thing that humans do.
Feel is not a strong argument, just to say that. So I feel like a lot of science comes down to the problem of the solutions often don't feel good. This is what I think about consciousness. I think there's a perfectly reasonable solution to the hard problem of consciousness. It's just really unsatisfying. It's just very boring. And I think that's like the bigger problem is the philosophers have to get their head out of their own asses to see that, there's an answer. It's just really boring. And look, I expected intelligence to be more than matrix multiplications too. But here we are. There are these like scaling law papers. I don't know if you've read the Kaplan paper. I also gave a great talk about this. I know it's on YouTube yet or not, where they do GPT type models, scaling models on different modalities, on video, on images, on sound and things. And they find the same laws, the same power laws, like shifted by constants, but based on the base entropy of the actual information. But it's like learning video was not much harder than text, or might have even been easier. Like the entropy of text a single word has very little information, but has a very high entropy because it's very hard to predict what the next word is. But if you have a frame of video, it's actually not that hard to predict the next frame of video. Like the mutual information between two words is very low, but between two video frames is very high. And it seems to like balance out. Again, read the paper. I'm like, and so it's like, we should taboo the word reasoning. Is that like we should at least define the word reasoning.
Just before we taboo it, because I want to ask one more follow-up question. There seems to be a difference between because you're talking about this generating function and modeling that, and I can believe it. I'm sure if we made a GPT-style model for predicting frames of video, it's at least an order of magnitude harder than doing it with language. I really hope that someone like Google can pull it off. But I believe it's possible, and I believe it will work really well. But it's completely different to the kind of scene understanding. So if I interact with such a model and I ask it questions about what it's learned, we're in the partial information domain. So I now need it to reason that I didn't actually see the tennis ball, but it must be a tennis ball because we're on a tennis court and you only get tennis balls on tennis courts. That's the kind of system 2 reasoning that we do. I don't really understand how the model would do that reasoning.
All right.
Well,
so
simply by correlation, it's seen so many videos of tennis balls on tennis courts. It might reasonably. You can learn that sort of thing just by association, and the same goes for actually the corner table wants a beer. You can simply learn this by hearing so many. You wouldn't understand that if you hadn't heard that before many times, right? It's not like you intuitively are like, oh, of course, because I actually, when you said it, I heard that the first time and I was like, wait, okay, what's going on? All right, so it must be some missing thing. And then I reasoned my way, but because you said it was ambiguous. If I just heard that, I would be like, okay.
Yeah, funny enough, same with me. When I first heard it, I was like, why is he giving the table a beer? That was also the first thing I thought about until I reasoned in my head. I played too much Dungeons and Dragons where like magic items are sentient. And the thing, the way, if I like think about how my brain does it, it was like, okay, he says I gave the corner table a beer. my brain pops up a prediction of what that looks like or what that was like, correlates the different, it was like the visual module with the hearing module or whatever. It pops up a picture of Tim handing a table of beer. And that's weird. Like I have a high entropy. This is a high loss. I had to predict some really weird tokens for this to fit my model. There's a very low probability that this is an action that fits into my model. And then I'm like, okay, let me try a different model. Okay, maybe he was just putting it there for someone else. He's like, oh, it's the people at the table. That's what he means. So I tried several variations, several beam searches, and I found one that had a low perplexity, that had a low loss compared to my other constraining models. And yes, I agree that GPT-3 probably doesn't do it. Though again, with a logic lens, it might do this. It might, for example, make guesses, these parallel guesses of table persons, and then successively guess, oh, actually he meant persons. That might be what GPT-3 is doing. I don't know if it's what it's doing. It might be. But that's what my brain does. It's just like it generates a plausible scenario based on this generating function that I've modeled. And then I have a loss on like how well does this fit into my generating model, forward, backwards. It's kind of like I pick the logits and then see how confused is my model if it had to generate these logits. And then I try to find maybe similar logits or different interpretations that are a lower loss in my head until I found an interpretation that made sense. But it's perfectly possible for you to say something that is unambiguous to you, but my brain just doesn't figure out what the hell you're talking about. It happens all the time.
But that hardly ever happens.
Oh, it happens to me all the time. What are you talking about?
What I find interesting is that when you think, it appears to you that you think in internal language. Like the whole process you described right now, that somehow happens as language in your head. Because you're talking to yourself and you're like, well, wait, no, well, okay, maybe that, and so on. And as of now, I still don't see something like GPT-3 doing actually that, like actually materializing its internal state as actual language tokens or discrete states or something like this. And there the question is, are we just post hoc rationalizing what we're doing as language and actually we think in some kind of latent space? Or is this still something that's missing from our architectures to achieve? And it's not said that to achieve the same goal, you must do the same things, but that's just something I observe in myself.
Yeah. So like I don't know if you've ever heard of it, there's the theory of consciousness as the CEO. So like consciousness is like the thing that sits on top of the brain. And it's also the theory of consciousness as the press secretary. Is that as we perceive ourselves as the talking person. It's not the person making decisions are made by all the like big brain stuff in the lower parts of the brain. And we are just there to rationalize it, to explain it to other humans why we did the things, whether or not that's actually true. So again, moderately divisive, controversial disclaimer here. I think there is overwhelming evidence this is true. I think there is extremely powerful evidence that the primary purpose of talking is to bullshit your rivals. And such. And like information seeking is like a secondary, like a happy accident that we can also do that. Because the obvious example is if like language was only about exchanging information, then we should have huge ears and very small mouths because we never want to give information to our rivals, but we want to absorb as much information as possible. But humans love to talk. Like I'm the perfect example. I love to talk all uncontrollably. I want to talk all day. And so I think there's a lot of, again, it's like these just so stories. It's like evolutionary stories, just so stories. But I find it to be not implausible that a language evolved as like a mating signal, as like something to like bullshit our rivals or something that then also turned out to be useful for other things, which is often in evolution. And it feels to me that probably what happens is we have some parts of our brain that take in latent states and output vocal commands. That's what I probably think is happening.
So you think that you're a press secretary?
Yes, I do. Because let's be honest, is that sometimes I get really angry at something and I'm like, where the fuck did this come from? Like, why am I so upset about this? I don't know. Like, it's fascinating if you just think about like yourself, like how little control you actually have of your brain. If you just get very emotional about something, you can control it. There is a non-zero amount of things you can do to control it. But it's not a unified whole. I find it very, maybe other people are unified. I am not unified. I don't feel unified. I feel like I'm composed of different parts that talk to each other, that make bets or make alliances with each other and stuff like that. That's what I feel like. And I think reading psychology literature, it's very common. I think that's probably how all people work. And I think this is probably an artifact of the slow information speed in the brain. I think that if the brain had very fast signals, this probably wouldn't happen. Like if we had enough processing power to integrate all the information. Oh, it might also be a Bayesian thing. It's like integrating all of your beliefs is actually like MP hard. Or actually, I think it's P-space hard. It's like very hard. And it takes a lot of compute power. That's why people have cognitive dissonance all the time. That's why we can often believe two completely contradictory things, because they're just in two different parts of the brain that don't talk to each other. And then we don't feel a problem. It's just that when those things clash, when we have some traumatic event where those things interact with each other, that then suddenly we have to resolve this and we have to like go to psychotherapy or whatever to like think about that and find a solution to this thing. Humans are extremely inconsistent. They're not integrated. It's all these different parts talking. In many ways, it feels to be like, I think GPT-3 is close to one part of the brain. I don't know what one part means, by the way. Whatever the fuck that means. Like, maybe the brain is like, maybe it's a continuum of just, maybe there's modules, maybe it's continuous. I don't know. Those modules bleed in over each other in like this continuous space or something. I don't fucking know. Maybe it's, purely discrete. Like you have one chunk here and one chunk here and one chunk here. I don't know. I think this is contentious in neuroscience.
I think the topology question is really interesting, and Yannic was touching on this as well, that is it a radial pattern? GPT-3 is quite interesting because it's just left to right. And I think that fits in with your hypothesis, Connor, that it's basically a generating function. What would be interesting is if it had a strange topology, but also if it had cycles, because I assume at the moment we're talking about it as if it is an acyclic graph, as if it's like
absolutely.
a kind of tree structure. But what would be interesting is if it did have a reflexive property and there were branches, and then there would be the kind of recursive self-improvement loops, and then it would, after some period of time, it would go back into the main branch, and there would be different specializations in different parts of the brain.
Absolutely. And I think this must happen. 90% of the connections in the brain are actually feedback, not feed forward. The vast majority of information in the brain goes feed back, not feed forward. To be fair, the concept of feedback and feed forward in neuroscience is kind of weird. Is that like the feed, like sensory is feed forward, but feedback is also what gives you motor controls. It's a little weird, which we would normally call feed forward. It is weird, but it's very clear the brain uses feedback everywhere. So like my hypothesis is I think a lot of these feedback connections implement something similar to backprop. Not exactly backprop, some local version of backprop or some kind of Hebbian learning rule. I think a lot of the functions are for that, but there are extremely long-range feedback connections. And what those probably are like communicating these constraints backwards. Is that it's like you say, I brought a beer to the table. That's a constraint that's in my like top level, that's in my working memory. And then it feedback connects. It sends like some kind of constraint to the lower hidden layers. Okay, you have to generate some logics that fit this pattern or that can explain this pattern. And then all my different modules start firing, all my different models. It's like I expect that the brain is actually composed not of one GPT-3, but like 1,000 GPT-3s in parallel. They're all like learning similar, but not the same thing. And then we have top K function that says, okay, we take the 10 best outputs of our 1,000 models or whatever, and then that's our explanation that we work with or something like that. There's a lot of neuroscience evidence for this kind of stuff, but again, I'd like to put a moderately contentious issue on top of this, is that not everyone agrees with this. Neuroscience is weird, but that's my working model. Like I think I'm pretty confident that something like this is going. There's some things we don't know, like how our reinforcement learning plays into this, because we obviously learn some things preferentially if they're like nice, and it's very unclear how that works. So I think there's a guy called Steve Burns. He has a weird name, sorry. I'm less wrong, who writes a bunch of sequences about neuroscience. And I love he's very unapologetic about saying, this theory made no sense to me, so I threw it out. And I think this makes way more sense. I love him. And I've already heard neuroscientists telling me he's completely wrong about everything. But then when I asked them, what is he wrong about? They would just say, you have to read a textbook. And I'm like, come on, man, that's bullshit. Like, I think he has a lot of really good theories and he has some theories, which are probably like 50% wrong, but I think they're 50% right. Is that there's something, it's like what GPT-3 is missing is some kind of recursivity, which might just be Monte Carlo tree search. It might be something very simple. It might be something more complicated. And some kind of sense of reinforcement learning. Is it some way of saying these states are better than other states, and we want to preferably learn simulations of states that bring us into this scenario or something like that. I think there's something like that going on.
But I suppose my next question would have been, why hasn't this already been done? Because it seems like we can do this now. We can have some kind of adversarial pattern. We can have looping semantics. We can have specializations. We can have integration pathways and so on. But then you can just keep taking this to the next step and the next step. Do we need to have this huge heterogeneous architecture to model intelligence? Or do you think it's simpler than we realize?
I think there is a good possibility that I'm not to say like 100%, but I say 30% 30% we can get superhuman AGI by just making GPT-3 bigger. Like literally changing nothing else about it. Just adding adding a reinforcement learning controller on top. Is that it just GPT-5 without any changes, 100 trillion parameters, is just going to spontaneously be smarter than all humans. I say like 30% chance that's going to happen. I still don't think it's the most likely thing. I still think, especially like local learning rules. I think a lot of it is hardware lottery. So like, for example, one of the reasons those recursive things don't do is that they don't run well on GPUs. I think that's just honestly one of the reasons. This is really hard. It's really inefficient to do these kinds of things. Like I generally think that transformers are not really magic. I think this is, again, wild speculation. But I think the reason transformers are currently the top architecture is not because they're like better than LSTMs or RNNs or something, but they're just more efficient on GPUs. Is you can run a much larger batch size and much more efficiently on transformer than you can on LSTMs. And they actually OpenAI actually checked this in their scaling law paper, where they showed that actually LSTMs just perform like a constant worse than transformers. And it is a large constant, but if you just put in enough resources, you will reach transformer performance. It's just that the LSTMs are less efficient. So I could imagine in the future, if we have enough compute, LSTMs doing what GPT-3 does, or whatever other architecture we might have in the future for these kinds of things. Who the hell knows? Maybe some kind of very sparse architecture. The brain is extremely sparse, so maybe something like that will come out.
LSTMs are difficult to train, as you say, but they do have some limits. They have this forgetting problem. And certainly when Transformers XL came out, it talked about this context fragmentation that was apparent when you only had an input size of around 512 tokens. And that made a huge difference to the performance. And they were implying at the time that LSTMs just couldn't really get past that. But you're saying it's the computational problem more than the forgetting.
There's always something when I hear you just have to throw in more resources and the scaling is a constant worse and so on. I can make an LSTM that you always have 500 input tokens, and the LSTM basically has 5,000 weights. And the first 10 weights exclusively only carry information from the first token, and the second 10 weights exclusively carry from the second token. And there is never any LSTMing happening, basically. So there's just a feed-forward mechanism that, like a transformer, would act as once in a layer, but it just carries over all of the information from all the tokens, and then at the end it does like its feed-forward layer or whatnot. So I don't like when at some point we're simply talking about linear algebra with nonlinearities, and maybe in a transformer these happen more efficiently, as you say, but at that point, it seems like it's no longer about the architecture itself, because if I scale an LSTM, I can get around it being an LSTM. It's then just another matrix multiplication with a nonlinearity. So I don't know. That would just be
if I had to speculate a little bit here, is that I expect we're going to find that we're going to, in the near future, find some kind of unifying grand theory of neural networks. We find out, actually, the architecture is completely irrelevant. These are just like special cases of some more general algorithm that searches some kind of real space of programs or something in some kind of efficient way. I think honestly, neural networks is a candidate for the worst naming in history in science. Is calling them neural networks is such a misnomer in so many possible ways. It would be way less cool if we called them matrix program search or something. But that's what it is. It's a first order optimization algorithm of numerical algorithms in some very large high dimensional space. That's what they are. They're not neurons. Maybe neurons do the same thing. That would be a coincidence. Is that what it is? Program search. It is search, and if you have a large enough space of programs that you search through, no matter what the programs are made out of, whether it's Turing machines or matrix multiplications or things, you get Turing universality very quickly. Of course, those kind of proofs aren't really useful because in the limit, anything is possible if you have infinite compute, blah, blah, blah. So what's surprising about these big matrix multipliers is that it seems that very humanly useful programs are pretty early in the priors, are pretty accessible, all things considered. Because you search throughout Turing machines and try to find a Turing machine that classifies images. That's going to take a while. But turns out that for some reason, I think we don't yet know. I expect we will have a theory of. And there's some manifold geometric interpretations of neural networks that are like emerging. I'm not an expert on that, but I expect that we'll find some mathematically elegant explanation of why this space of programs is particularly fruitful. And I expect that we will then see that, oh, transformers happen to give us a bias in this part of the space or what. I mean, that's what CNNs do. It's, they explore the regularity. It's a better example than transformers.
I love this really interesting, this framing of a program search. I think it's the first time I've heard someone articulate that, actually. It's fascinating. But the problem the neural networks seem to have is you need to have a very dense sampling of the input space. So it seems intractable to me to have a program search across the space of all possible programs. Is that something that we could really achieve?
Oh, yeah, absolutely. It's absolutely nuts, and it works. That's the problem. Is it like, if you explain to me Platonic Connor outside of reality, if you explain to you neural networks is, I'd slap you and say you're fucking stupid, that'll never work. You want to just differentiate reality? What the hell's wrong with you? You need to take some higher math classes. Oh yeah, calculus is going to save the universe. Sure, buddy. Turns out it does. It's just, we just have to accept the facts. The neural networks work. They don't work for everything. They don't work perfectly, but they do work. We have, voice recognition. We have picture recognition, blah, blah, blah. They're not perfect, but those are really useful programs that we couldn't program. You can't sit down and write a Python program that is as good a dog recognizer as Inception is. You can't do it. It's just not possible. We've tried for decades. It doesn't work. And neural network, that's why all these GOFAI people are bitter. Sorry, GOFAI people. Your stuff doesn't work. It's not that it's a bad theoretically. I think GOFAI is fascinating theoretically. I like reading GOFAI stuff, but I read it recreationally. It's just, the truth of the matter is that our computers already won. Like the program search over these like large spaces of programs in the abstract can't work. So in the most general case, this can't work. This is an halting problem, complete problem. This can't be done. But if we just searched over Turing machines, we would never find a Turing machine that does anything useful ever. Even when we spend the entire universe searching Turing machines, we will never find one that does something useful. Maybe we'll find one that adds 2 numbers or something after 2 billion years. But for some reason, something about the priors that we put into these matrices, about like this thing, something about that just biases it towards programs that are useful to humans. One of the reasons might be that quantum physics is basically vector algebra. That might be the reason. Like that might actually be the reason. Is that just the reality is just made of vectors? Maybe.
You don't think it might have something to do with the fact that humans have to be fairly energy efficient, or brains in general? Like nature had to make brains quite energy efficient. So the sort of things that brains can compute are not that complex, and 2, must be very useful to these life forms. And I know you don't like the naming, but we have modeled these things after neural networks, after the brain. It's not that surprising that this space comes to these programs, because they're both very easy, and we feed in some of the similar biases and constraints that human brains have. So in a sense, that it's in the name why this might work, why these biases exactly match. And we know that these neural networks are mainly good at the things that the human brain is good as well, like speech recognition, like and so on.
Yeah, that's perfectly fair. So again, I'd like to say, I think it's an open question whether the brain does something like backprop or not. Like it might turn out that the brain is just actually matrix multiplications. I don't expect it to be true, but there is a non-zero chance that is true. It's like when I think about artificial neural networks, like I think of the perceptron. Have you ever seen the perceptron? Not a perceptron, the perceptron. It's great. It is the first perceptron. It was an actual physical device that was actually built. It was actually dials for weights that you had to move. They're actual physical relays that you had to move. It's great. And that's what a neural network is. A neural network is a very large amount of dials that you twiddle up and down. That's what a neural network is. And then you flow information through that. And as I say, Turing universality is such a powerful concept. It's really hard to grok how powerful this is, that you can build a computer out of your Turing machine, out of neurons, out of cables, out of rocks falling down. I plan on writing a blog post called Rocks Fall, Computation Happens, where I describe how even a rock falling down is computation in a way, if you just set up the right rock falling in the right direction. And it's so yeah, the Turing universality thesis basically says that you can approximate, you can any system that is as powerful as a Turing machine can simulate any other system. So there's no other system that can, with at most a polynomial speed decrease, not simulate another system. This is crazy. It's hard to overestimate how unintuitive this is. Like, how you should be surprised that this is true. You should be absolutely shocked that this is true. You're saying that if I build a machine that's 2D instead of 1D, or that can do this or do that, it's not stronger. It does not come better. It's still just a polynomial amount slower. And this is explained by, you can just always add a compiler at the front of your program that just compiles the program from the other language into your language. And this is at most a polynomial operation. So it will be slower, probably, but it will be a polynomial slower. The thing is, this polynomial does matter in practice. That's why we don't use Turing machines. We use, von Neumann architectures, because the polynomial of Turing machines is really bad for our problems that we care about. There are problems that are very efficient on Turing machines, but there are other problems that are more efficient on other architectures. And so neural networks are in their way a space of computation machines that have a certain polynomial. They have a certain bias towards certain programs that run quickly. There are certain programs that run fast on a neural network that would run slowly on a Turing machine, or whatever. Everything runs slowly on a Turing machine. I think this is also what happens in the brain, is that the brain is like a very parallel machine that's approximating with this polynomial slowdown a serial machine. Because humans are really bad at thinking very precisely for many steps. But computers are very good at that. But still, we could approximate each other in theory if we have this slowdown. And so what I'm saying about why it's fascinating that these matrices work is that it seems that somehow this polynomial, this slowdown, the biases that this computing paradigm has, seems to be very related. It's very useful to the ones that humans care about. And I find that a fantastic scientific discovery. I think more people should talk about this. This is a discovery about the universe. I think this is a basic science discovery and a basic science question that we should be asking ourselves. Why is this the case? What does this tell us? And as I said, my best guess is the universe is just actually made out of matrices. That would be my guess. And therefore, it's efficient to simulate it on matrices. That would be my guess.
Coming back to GPT-3 and this box, right? We've come to associate basically a web page with a box on it with Google, right? That was how Google started. And my initial instinct, I think everyone's initial instinct when seeing the GPT-3 box, is to answer a question, right? It's like, how are you? Or something like this, which is not the thing you want to do with GPT-3, because once you understand how it works, it just continues text and so on. Do you have any tricks or that you've already found out, like tips to share? What is the new way that humans have to learn how to interact? How do you ask it a question? How do you, because when you ask a question, it will simply continue a text as if it were on a website, right? It will not give you its opinion. It's even hard to talk about something like this. Do you have any sort of things that you realized, that's how I have to do it, or here is a neat little trick to do something?
I'll give you a bit of a cop-out answer, because I'm actually don't consider myself particularly proficient in GPT-3. I've played with it a lot, but not as much as other people. Read Gwern for that if you want the expert tips on how to use GPT-3. There's a really great essay called, what was it called? It was like UX as alignment or something like that, as a bottleneck on alignment or something like that. They basically make the argument so they start with this example that two Navy ships crashed into each other. And there was a warning for that, but it had the same color as the background or something like that. And so just no one noticed it. There's an argument to be made that the system failed to communicate an information to the user who could then communicate their intent to the machine in a way that achieved their goals. So what makes Google amazing, and the reason everyone uses Google, is not because it indexed all websites. Alta Vista did that too. That's not exciting. What's exciting is that Google is fundamentally a UX company. They found a way to make it easy for us humans, to make it simple for us to communicate what we want from the machine and get answers that are useful to us. This is an extremely hard problem, especially with such a teeny window, such as a few words of text. Honestly, Google is such a goddamn miracle that it works at all. I can just enter shit at Google, and if it's on the first page, I don't even look. If it's on the first 3 links, I don't even bother. It doesn't exist.
You're too young.
It's yeah, I might be
I remember that time.
Yeah, but like
the best place to hide a dead body is on page 2 of the search results.
Yeah, absolutely. And I do remember it slightly being worse when I was younger, but honestly, it is that good. That's the thing. It just actually is that good. Is I don't have to look at the second page ever. Like maybe the third link, maybe the fifth, if I'm really unlucky and looking for something obscure. But for the most part, I can just enter 3 vaguely related words, and it gives me exactly what I want. And that is not because my words were particularly great. It's because Google is great. It's because there's so much brain power and engineering effort went into making a Google that is aligned to me as a human. If an alien used Google, it wouldn't work at all. Even if it spoke our language, it would ask something that Google does not understand and would just spit out garbage because it's an alien.
You're contrasting Google and GPT-3, and Google is this hierarchy of systems. I think what really made Google overtake AltaVista and is it the early 2000s is the PageRank algorithm, which is a ranker. And now they have a series of rankers that fire in sequence depending on how many results there are. Presumably, they also look at how many people are clicking on the links. They do some kind of collaborative filtering. They do some deep learning models. They do a whole bunch of stuff. And they also route your query, and they're looking at semantic stores, and they're looking at knowledge graphs. And they've built this incredible system for doing information retrieval. And GPT-3 is just like one black box.
Yeah, and that's the thing. GPT-3 is in Google. GPT-3 is Google's data center. And now we have to build a Google on top of GPT-3. That's my point. GPT-3 is like AltaVista. The data is there, but prompting is really hard. And I expect the next $1 trillion company of this sort will be the one to build a Google on top of GPT-3. And let's be honest, it's going to be Google again. Google already has its models internally. Like I've actually heard from, this is hearsay, don't take this word, but I've heard from Google people that they already have a GPT-3 model in-house. They already trained one and already experimenting with it. So I expect that to come. Of course they do. Like, why is this is not anything, surprising? Of course they do. This is not surprising. And you can even, if you read the papers, which group did it, it's not even hard to guess. And so I expect that probably Google, probably Microsoft, and like a few of the other things are currently have their like secret black ops divisions trying to build a Google on top of these models using clever prompting, like Siri type stuff and like hard-coded rules, but then also stuff like reinforcement learning. I already said this, I'm a huge fan of Paul Cristiano's work at OpenAI. They did a great paper called Learning to Summarize from Human Feedback, where they basically use human feedback as reward signals to train a model to summarize, like a GPT model to summarize text better than humans do, actually. And this is actually really fascinating because you can, with reinforcement learning, you could like, this is what Google does. Is you can't do supervised learning on Google queries. Like there's no supervised data there. You have at best a reinforcement learning. So like, did the human click on the first link or not? Like the best you get. And I expect that in the future, with like reinforcement learning, with Google type services, Siri type hard-coded rules or whatever, there's going to be interface like that. I expect GPT to be integrated into Siri within the next 5 years.
This gets into one of the other points I wanted to make. I want to talk about the database example from Matt Brockman. Now, the dream here, and you framed this up the other week, is software 3.0. It's prompt engineering. And Yannic is making the argument quite a lot that the only problem is that, and you've just made, it's very difficult to design these prompts. But I must admit, I've got no agenda here. I would love it if GPT-3 worked. I certainly have no interest in making it look bad. But I've tried to do prompt engineering on GPT-3. And on the database example, there's a dichotomy between saying to GPT-3, I want to build this application, and on the other hand, letting GPT-3 lead you. So on Matt Brockman's database example, it had in bold, how old is Tom, or something like that. And it was made to appear as if Matt Brockman came up with that prompt. But that actually was one of the things that GPT-3 led you to ask, if you put in the bit above.
I'm more interested in GPT-4, 5, 6 than GPT-3. Like GPT-3 was not explicitly trained on code. It was not explicitly trained with this goal. And I expect this. I think the most important paper this year, other than GPT-3, is Learning to Summarize by Human Feedback from Paul Cristiano's group. I think it's probably the most important paper to be published because it shows a roadmap for how these problems can be solved. Like you asked the good question, how can we, communicate to GPT-3 what a good program is? Like this is such a abstract concept. And I expect that to be very hard. But the question is, how do we communicate to humans what a good program is? How do we teach humans? At the end of the day, reinforcement learning. You write a program that works, you write a program that doesn't, you write a program that your boss yells at you, you write a program your boss doesn't yell at you. At the end of the day, humans don't get magic information. We don't get magical insight into code. I've worked with interns. I know that we don't have magical insight into coding. And so I expect that in the near future, again, Connor predictions for 5 years in the future, maybe next year, Visual Studio Code will have a new IntelliSense add-on running on GPT, which will be a GPT trained with reinforcement learning on good coding style. And it will suggest to you, you can press a shortcut, enter a thing, write a quick sort here, and you click a button and it'll just paste it. And this will be a really complicated thing in the background. This will be trained on hundreds of thousands of reinforcement learning examples, and there's going to be different models for different use cases. It's going to be a huge, complicated Microsoft scale thing in the background. But it's going to fundamentally work on a unsupervised knowledge base that's trained on all of GitHub or whatever, a reinforcement learning on top of that, which learns how to use this thing, and then that's how you actually extract the information. I expect that the humans need a assistant, a reinforcement learning assistant, a brain thing on top of the GPT that helps extract the useful information. I think to a large degree, that is, for example, that's to a large degree what the speech module in the human does. Is I get a lot of feedback if I talk good. I see people smile at me, or they say, "Oh, that was really fun to talk to you," or something. There's lots of feedback I get in this sort. So my model learns, okay, here's the hidden state of what Connor wants to tell these people. Now how do I say this in a way that's fun for people or that people will listen to me for? And that's fundamentally a reinforcement learning problem.
It is, but then you have the problem of evaluation. Because I wanted to ask this question as well, because GPT-3 is a bit finicky in the sense that there's lots of parameters to tweak. It's not deterministic because we do this stochastic sampling of the model. And if you do make it deterministic, it gets stuck in loops. So you want it to be stochastic. But then from a software point of view, it becomes very challenging to deal with because you get different results every time. Another thing I noticed is on this Matt Brockman example, it's so tempting for us to look at the results and we have this anthropocentric lens. So it looks like a software application. But what I did was I changed all of the words. So I changed database to be XYZ and I changed wants to be just some random letters. And I realized that it doesn't actually matter what the words are. It appears to be just doing pattern matching on the tokens. And then I'm starting to think, is it doing any natural language understanding? And is it doing any information retrieval? Or is it just pattern matching between where I'm putting the tokens and the prompt?
To be fair, pattern matching is Turing complete. So you could implement a database using nothing but pattern matching, or a string substitution or something like that. So again, we run into this universality thing of what's the difference? At some point, it's a polynomial difference at most.
So Yannic, what was your take on that database example?
Yeah, it just seems brittle, and it just seems like this is a thing that worked, and you might be like, whoa. It predicts the next query as well. And I'm not that surprised that if you go by the queries that it itself predicts, that it then gives sensible answers, especially if you fiddle around. We discovered you had to fiddle around pretty clearly with the words, like how you ask the questions and so on. And then it's not like it's not as impressive anymore. It means a different thing. This data point, it gives a different kind of evidence for what it's doing. And that was just that database example.
Yeah, I think it's a really good framing to saying that it's still impressive, but it's impressive for a different reason, or it tells us something different. Because again, try to get a high school student to do these examples. It's actually not that easy. If you tell a high school student X, okay, and Y, okay, what is X? It's actually not that. I would predict if you try these this would be a great YouTube video. Great YouTube video idea. Take a bunch of GPT-3 prompts and give them to high schoolers and see how good they do. I think that would be a great video. I'd watch that. I predict they do worse than GPT-3. They would give you less useful output. Not all of them. I think they would greatly outperform on certain queries, but I predict on many queries they would perform about the same level or worse. Because we as scientists have been trained, rightfully so, to not anthropomorphize our machines for good reasons. And I'm going to make the socially taboo suggestion that I think we should anthropomorphize GPT-3 more. I think GPT-3 is much closer in its flaws and strengths to whatever the human algorithm is than any other machine we've ever built.
I've already anthropomorphized all the image models when I made them do Rorschach tests and so on. Maybe we can do the same. Yeah, the hard thing is to ask it questions. That's what I find the hard thing. If it was like I've experimented with Facebook's Blender chatbot, which is also very good, right? It's way more limited and so on in what it can do, but it's also very good. And at least it has this notion of a conversation. It has this, okay, you, now I, now you, now I. And GPT-3 does not have that. So it is extremely hard to get it to do anything that you want. As you say, we need like something on top that we can give our input somehow, because I would love to ask it questions, but yeah. If it were something like BERT, that would be interesting too. If we can, leave out a certain passage in text and say, fill this in, please. This would be very interesting too. But all you can do is say complete. Please complete things. And that makes it just really hard.
One of the things that I struggled with is it's quite hard to know whether it actually understood or answered your question correctly. And sometimes if you just let it continue, it'll contradict itself and just do the opposite of what it just did before.
Yeah, of course. And again, it's because an artifact of how it's trained, how it works. Also, sometimes the sampling just throws it off. Imagine there's a 10% chance that every time you just speak a random word, every time you want to say a word, you just say a completely different word. That's what it is like to be GPT. Is that occasionally it will say something it did not meant to say, and you're not allowed. Like I've seen this metaphor. It's like GPT-3 is like a human who's forced to keep writing at a completely constant pace and can never go back to erase things. That's kind of what it's like, because it also gets exactly the same amount of compute for every word. Well, with humans, we sometimes stutter, we sometimes take a second because we have this particularly difficult word, which I think is what's happening is that we fit a token where our confidence isn't that high, so we beam search and we try a few different variants and then select whichever one turns out best. And this is implementable. If someone wants to implement this in GPT-3, that's doable.
Beam search is still a greedy search, but it's slightly better, isn't it? It's built on the best first search. But we can use the analogy here of AlphaGo. So you learn a model free policy, and then you do this Monte Carlo tree search, and then somewhere in that tree is a really good move. And it's similar to what we have here. So you're saying we're only one step towards where we want to be. We now have this GPT-3 model, and we need to do some kind of tree search, which is better than the kind of naive, greedy searches that we're doing. And somewhere in there will be the correct response, which will seem to be intelligent and seem to be doing reasoning.
It's probably one step. I don't think it's going to be everything, because people have done this, and as far as I can tell, the results were usually pretty underwhelming. It's like implementing, like I've heard from OpenAI people in personal discussions, they said they implemented beam search and GPT-3, but it just wasn't that impressive. It just actually did not make that big of a difference. It didn't make no difference, but didn't make a very large difference. So I expect that probably it's going to be this multi-model thing, is that we're going to have these like multi-modal constraints. We're going, like, what the brain does, it has constraints. Is that your speech thing might be saying one thing, but the visual thing says, remember the object was red, you have to call it red. But the word red doesn't fit. Oh, scarlet, that's a good word. I'll just say scarlet. Probably something like that. Or completely different. Who knows? Maybe, as I said, GPT-3 is already doing this internally. It might be that every layer is a kind of guess, a kind of beam search or of something. Probably not.
And I must admit, though, after speaking with Walid Saba, because I've gone from your position, which is absolute hatred of GOFAI people and all this knowledge graph stuff, to actually thinking maybe that they're onto something. I must admit that I'll probably do full cycle.
To be fair, I'm a big fan of Marvin Minsky. I think Marvin Minsky had a lot of great ideas that are like forgotten and underappreciated. I like his book, Society of Mind, was the first AI book I read, and it's still one of my favorites. It's really good. I think he was wrong that we're going to implement AI in Prolog or whatever the fuck, but there are good ideas there. Like, there are good ideas present. It's just not. There's just other things where it just doesn't work necessarily. Like, I'm a big fan of like type theory, like Haskell, and like all these like obscure like Coq, which is an actual programming language. I'm not saying an epithet of provable coding, proven programs and stuff. I think that stuff's super cool and such. But it's not going to lead to AI, is it? I don't know.
Yep. Thanks.
My pleasure.
Connor Leahy, thank you very much for joining us this evening. It's always an absolute pleasure, sir.
Absolutely. Thank you.
Amazing. And in this segment of the show, we talk with Walid Saba. Walid has had a huge influence on me after I discovered his writings online. He's a good old-fashioned AI person, and his specialism is in natural language understanding. And as you could tell from the episode that we did with him recently, his thesis is that natural language processing is not the same as natural language understanding. And after having played with GPT-3 for several hours, we got his take on what he thinks of GPT-3. We've been playing with this together now for a few hours, and in some ways it surprised us. But overall, what we said the other week about natural language processing is not understanding, blah, blah, blah. I think that the main point that you're making is it still doesn't help us with the missing text.
It's not even close. If I was them, I would try to make it more of a predictive engine for helping people do some kind of development or find relevant information, or it's a retrieval engine more than anything. There's no even NLP, let alone NLU. Come on. There's no understanding whatsoever. This is just an engine that has digested millions of textual patterns, and it will spit out something similar to your prompt. No, the word understanding it should not be on the same planet. There's no language capabilities whatsoever.
The text matching thing is interesting because we noticed that even if we change things to be gobbledygook or just letters, it still worked reasonably well. It didn't seem to matter what the word was. It was just the pattern. The other thing we noticed was that it seems to be dominated more by the prompt than the corpus it was trained on. So if you give it a prompt, that seems to overwhelmingly determine what the output is.
Don't forget, the prompt is the input to the network. So the prompt is that's your test case to the network. It's okay, I've seen all the examples. The prompt is the input. So it does all the activation. The prompt is the thing, right? The prompt is the new example. And so it's going through the network and saying, okay, I'm in this space. Okay, I've seen this pattern. And so it's a massive dictionary. It's a massive hash table of everything it saw before. But to put that in the context of language understanding, we're talking even apples and oranges. There is a use for it. I saw glimpses of powerful pattern recognition. Man, with 2 examples that can figure out a pattern. That's powerful, but don't sell it as something that it's not, right? That's my only issue with it. So I learned a lot by seeing it, actually. Yeah.
Could you define exactly what you mean by understanding and what you mean by pattern matching in the most succinct way possible?
Right. I think that's the main question, right? Pattern recognition, I wrote something recently about learning versus knowledge. You learn how to ride a bicycle, you learn how to play guitars, but that's different from understanding or knowledge. Like we don't really learn that the circumference of a circle is 2 pi r. We are told, or we discover it by deduction. Why we don't learn it? Because if I learn it and you learn it, we can learn it differently. Pattern recognition is a skill, right? And it's a function of what I see and what I experience, which is the ML paradigm, right? That's the machine learning paradigm. I saw all of these things. Now I know. We say I know how to do this, but you really don't. This is not knowledge. This is pattern recognition. I saw too many of these. So understanding is different. Understanding is binary.
I think I understand. So are you saying, though, that understanding and knowledge are synonymous?
Understanding and knowledge, not synonymous, but definitely if and only if they go together. But with pattern recognition, there's no understanding. When I start to recognize that this is a cat, I didn't understand anything. I know now what a cat looks like. There's no understanding. The understanding and pattern recognition are 2 orthogonal things. That if I start to recognize, when a child recognizes that this is a 7, they don't have any knowledge. They just know what a 7 looks like. Okay, in everyday, ordinary language speak, we say, I know what a 7 looks like. But the word I know here is is different from I know that water boils at 100 degrees centigrade, because that is a fact that I have no option in knowing it differently. I just, right. There's a, if you recognize dogs, you don't know anything. You just know what a dog looks like. We say I know, but there's no knowledge. So pattern recognition is a powerful thing. It's a big fraction of what we do every day, but it's different from understanding and knowledge. And in language understanding, the choice, you don't have too many choices. It's binary.
In a slightly different way, because Keith and I were trying to wrestle with this earlier. Pattern recognition, to me, that seems to be like the glue. So that's transforming from one space into another space. For example, we might receive information in gridded on a 2D planar manifold, like a CNN does, and we need to somehow transform that into a one-hot representation or just something, just so that we can work with it. So that's the glue. But then the knowledge, I know you've just said, I know what it's like to understand a 7, but also that there's some kind of an ontological structure. And when we have this structure, then we can do reasoning. And reasoning is super useful for what you describe as the missing information problem, because we can perform basic deductions. I'm in the missing information domain. I saw a ball shape on the tennis court. I assume it must be a tennis ball because I'm on the tennis court. Once we have the knowledge and we have some information, then we can do this reasoning. I think that's what you're getting at.
Reasoning requires a base to start from. Recognition doesn't. To reason, I need to base my reasoning on something. Let's call it the ontological structure. Let's call it the axioms of how the world runs, the physical axioms. There are axioms in the world we live in, right? You cannot reason from nothing, right? Pattern recognition happens from nothing. I just recognize cats, right? So the two are different. Pattern recognition is, I stumble upon something a few times and I now know what that is. Reasoning is a different beast. Reasoning requires a base. In language, it requires a certain ontological structure that guides how we understand few things and we take them for granted. The missing text, whatever, which is the missing knowledge that we have that has to come in to do the understanding. So in formal logic, for example, you reason, but you start with some axioms. Geometrical reason starts with some axioms of geometry. Reasoning in life has axioms called the metaphysics of the world, how the world runs is the base. You can't reason from vacuum. You can't. You need but pattern recognition happens in vacuum. There are objects that I see for the first time, and then I start to recognize them. For a child, when they saw 7, they didn't need anything else except their sensory input.
That's interesting. To bring it back to GPT-3 then, so I think what you're saying then is that it is a pattern matcher. It does information retrieval, but I assume you would think of that as within the domain of pattern matching.
I think, look, it was and it still is a great experiment, and at least it tested the hypothesis, does more data, the hypothesis that if I get to a point where I'm making the probability almost certain that I've discovered all the possibilities, and actually Chomsky would be happy to know the results, because he told them a long time ago, and they misunderstood actually his comment, that speaking of the probability of a sentence is a meaningless notion. What he was alluding to is the infinite nature of how many thoughts I can make, and thus how many utterances I can make to express that thought. And so even trillion over infinity is 0. You're still nowhere. So this was a great experiment in testing Chomsky's hypothesis that if you see, and I guarantee you, if they make GPT-6, GPT-10, and they processed all the text that has ever been written by humankind,
it still wouldn't be enough.
It would still be fooled by one little example that a 4-year-old understands in a microsecond. So,
could I press you on that point, though? So I understand your point. You're saying the domain of language is infinite, but it's not uniformly infinite. So if we did have a sufficient amount of training data, would it work 80% of the time, or do you think it would just be a complete waste of time?
That's Chomsky's infinity. And I'll tell you, it took me a long time to understand. Again, I'm not a Chomskyan, but obviously he knows a few things about the mind and language. What he was talking about is, look, and people speak of domain-specific NLU, and they can, if we circumscribe the domain and we constrain it. And the thing about language or any infinite domain, and that's why game playing is not a test for AI. Alan Turing was genius to consider language the test for AI. When you get to the infinite, right, all your probabilities are meaningless because there's no distribution. There's no, if you stop someone on the street in San Francisco, what they might say, you can predict with a meaningless probability. You don't know what thought I'm going to say. So no matter how many patterns you see, this is where they miss the crux of the problem in language. No matter how many expressions, if I put one of the prepositions in the sentence in a different place, the entire meaning is the thought I'm trying to express is now completely different. That's why they can do something in summarization and clustering, because the topic, the general theme, okay, you can discover because it's, I go back to compression. It's a compression thing. Okay, all this text, forget the nuances of the thoughts that are underneath this text. What is it about? It's sort of a compression. That we can do in an excellent way. You can give me the key phrases, that's compression too. You can. But to understand the thought behind a single sentence is not a pattern recognition, and all statistical NLU fails miserably. There's no probability here. Here's the thing. The thought behind every sentence is not ambiguous. So it's a binary decision. And that alone should tell you that probabilities don't mean anything. Look, if you take a simple sentence, average length, average, whatever, there's in any sentence at least 12 possible meanings, at least, if you count lexical ambiguity, the fact that different words mean on average 6-7 things. If you take the structural ambiguity, because you can parse a sentence at least in 3 different ways, some of them 20 possible structural breakups. If you combine that with scope ambiguity, and of course you have to multiply them because it's the combination. Any average sentence has at least 20 possible thoughts underneath it. But guess what? The actual thought that it is conveying is one. Otherwise, we will stop each other every time and say, wait a minute, what do you mean by the previous sentence? We know what do we mean. So out of 40, 50 possible meanings of every sentence, the decision is binary. Either you understood it or you didn't. So there is no place for probability. There's no place for probably you mean this. What do you mean probably? That's what these guys miss. Language is a binary decision. If you want to do understanding, if you want to do summarization, hey, you can allow 3 possible interpretations. And because you're trying to get the gist of this, you're trying to do compression, you can do. Understanding is uncompressing out of the 50 meanings of this utterance, the meaning. It's a different problem. That's why NLP is a different discipline from NLU. I'm even suggesting for the community to call NLU something else. It is not about processing text. Language understanding is about uncovering the thought behind an utterance. And that is a binary decision. There is no approximation. 0 degrees of freedom.
This is fascinating because I must admit, since speaking with you, Walid, it's opened up my eyes, and I can't unknow this information now. I see it everywhere because now I know what to look for. But just to sum up a little bit then, so I think I personally agree with you. My friend Yannic and Connor, that they are still tending towards the statistical.
There's this trend, which is unfortunate actually, to redefine success. A colleague of he's a friend / colleague, he's a UCLA professor, wrote a nice article in ACM that we are claiming a lot of successes now in AI, not because we're succeeding in AI, but because we're redefining success. So One way to do this in language is to say, I don't have to fully, and I've heard this. Imagine rational people, for all intents and purposes, say, who says we have to understand language like we do? So we want to redefine success just because we're so passionate about deep learning. It's funny that, no, we do reasoning. I can prove it in 20 seconds. We reason actually a lot more than we think, because we subconsciously reason even, and formal reasoning. If then, we do reason, and language understanding is binary. It's not approximate. I can prove it again in another 20 seconds. So one way to solve a problem is to ignore it. Sure, there is this trend. Who says we need to do this? Well, if you don't want to do language understanding, then don't. But don't claim you're doing NLU. Okay?
Because I think some of I've tried to understand the thread of thinking here. I think some of these people are trying to go the other way and almost say that human intelligence isn't what we think it is. It's more procedural. It's just a generative function, and we're not doing any reasoning either.
It is procedural, and I am a physicalist, and I am a materialist, and there is a program that can simulate the mind eventually. So I'm in that camp, definitely. I don't believe in any supernatural powers or the soul or whatever. The mind can be formally described at some point. All I'm saying is, from data and observation alone, we can only get what other species get from sensory input, pattern recognition skills. We have a lot more. That's all I'm saying. I'm saying our mind is not the mind of a rat. It does a lot more than pattern recognition. And that's one way to tackle some of the things we do. Yes, we do it. Yeah. And it's a useful technology. We do a lot of pattern recognition, but we do reasoning. We have knowledge. We have a mind. And the mind is not just a pattern recognition machine that, no, we do reasoning. Actually, I think we are born with some logical axioms. Like, for example, a 4-year-old, if you ask him to put the laptop in a briefcase and it doesn't fit, try to tell him to put it in a smaller briefcase. They wouldn't, because they know if it's smaller, if it's bigger than this and this is smaller, they know this is if then. This is transitivity. So we are born with transitive logic. If X is bigger than Y and Y is bigger than Z, we are born with it because I never taught it to my kid. They know if it didn't fit here and this is smaller, and I say, okay, try that one, they would say, Dad, come on. They did the transitive logic. Animals cannot, animals do not. We are born with a mind that does reasoning. The evidence is, I hope I don't have to prove that, but and that you cannot get that skill from data. That's my view on the whole thing. We have something else. So to say, I was shocked the other day. I read a quote for Jeff Hinton. Before he made some comments that I said, okay, there's some sanity here. And then he made the other day a quote that he said, eventually deep learning will learn everything. Don't make statements like this. Don't. Statistical correlations is one useful thing. There's a lot more in the mind. There's ample evidence. And not everything is approximate. There are facts that are true in spite of us. We have nothing to do with it. We simply discover them. We didn't learn that the circumference of a circle, again, I go back to that, it's 2 pi r by experience. We didn't sense it. It is a fact, even if humanity never existed. So it's not up to us or our sensory input or observation. If humanity never existed and there was this vacuum in the universe, the circumference of a circle is 2 pi r.
Indeed.
And I can give a million other examples. So we didn't learn this, and we are, and I believe we are born with a lot of that. We are born with a lot of this basic logic.
Fantastic. So I think we agree then that GPT-3 isn't demonstrating natural language understanding. But the other couple of things I noticed, it was pitched as a kind of software 3.0. So through prompt engineering, you can make it do something akin to software. But I think what a lot of people didn't realize is that it's a stochastic sampling method using some kind of greedy tree search type algorithm, and you're probabilistically sampling from GPT-3. So different results every time, cumbersome, using different parameters. Doesn't really seem appropriate for software, because for software, it needs to produce the same results every time.
And we tried a few things, and actually, I was almost overly excited when we did, because it can recognize patterns. So if you give it a list and you give it the output as, let's say, arranged or sorted, it can figure out that you're trying to sort a list or whatever. But apparently, it's also fetching similar examples. When we changed the name from, like we tried length and size, for example. So length of a list that had 5 elements, it gave us 5. And I was, because for a long time I worked in program transformation and automatic programming, the dream of generating programs from, if you give me a couple of high-level specs, I can discover the program. So I was excited for a few seconds, and then we said, and we gave it a definition, remember, like an actual definition of the length. And when we applied it, it gave us the length, but apparently it was using the keyword length. It knew that length, list, they want the length of a list. We tried size, it worked, because in some programming languages, it's size. But then when we changed the function name to gibberish, because the function name should be irrelevant, the specification of the function is the semantics of the program. It was horrible. So it's even fetching size and length from memory. The thing that did impress me, I should say that, we go back to this pattern recognition. It's so powerful at detecting your pattern from a prompt, and we tried sometimes, we just gave 2 examples and it picked up the pattern. That's impressive, definitely. But if we go back to language and understanding, in a way it confirmed what I know and what I suspected, that it's memorizing tons of textual patterns, and then it's saying, okay, your prompt looks the closest to this, because your prompt really is the input to the network, and a certain place is activated because that's where it saw a lot of this. That's all it's doing. So it's not even close to anything we call understanding. Yeah, I think it's unfair to use the word understanding when it comes to language with GPT-3, but it's a nice experiment.
I've come round to your way of thinking.
Yeah, we're too far from that. Language is, there are examples I can give. We didn't get to resolving scope, and that beast cannot be just from examples. If you look at what a child is doing, resolving scope, resolving anaphor, resolving pronouns, and they answer you as soon as they hear it. If people that didn't work in computational linguistics will never appreciate this. That's why the data-driven, it's hard to explain to people that are doing just statistical data-driven inputs on language. If you go back to some of the really hardcore algorithms, when you're trying to understand a language, you build a stack and you put all the references so that you go and resolve the reference with entities that were discussed before. The procedure is so complex that, what's her name? She, in one conference I saw years ago, she said, if you work in computational linguistics, real language understanding, for several years, you might say, you know what, there might be a God. Like, it's such a complex problem, right? Just resolving references, resolving prepositional attachments. I had pizza with my kids. You didn't put your kids as a topic. I had pizza with pineapple was a topic, and children resolve that. So we're redefining success, unfortunately. We're saying, okay, It looks good. It looks good. Well, okay, but you're trying to solve a different problem. My main issue is be scientific about your claims. GPT-3 is going to write stories for us. That was a headline in a respectable newspaper. No, GPT-3 will spit out stuff it saw before. That's it.
But the fascinating thing is, if you Google the stuff that GPT-3 gives you, you'll never find it. It comes from a variety of sources, and it zips it together, and so there is something quite interesting about that.
Right, but you will find it in different places.
Oh, indeed you will. But what's interesting is that it is still inside the convex hull of information that already exists, but it's been stitched so finely that it's almost novel.
Yes, there is. It's an achievement to know that this goes with this, right?
Indeed.
Right.
But anyway, Walid, Saba, thank you so much for joining us again. It's an absolute pleasure.
Thanks, Tim.
In this segment of the show, Keith, Duggar and I have a conversation about why do we use machine learning? Is it to do things that we can't write code to do? And also we talk about the dichotomy between pattern recognition and reasoning. Computationally, what are the difference between the two? Hope you enjoy it. You're right. Most of the time with GPT-3, you can just write the same thing with code and it would be better. But that begs the question. The main reason we use machine learning is because you can do things that you can't write code to do. And that is still the case for a lot of things with GPT-3. So you can do some basic sentiment analysis or something, and it would give you results that you could not explicitly code. Is that a fair statement?
Yeah, so I wonder why a lot of the times we're judging GPT-3 or playing around with examples that are things that we can code. I don't need a neural network to loop through items 1 through 100 and print them out or something. And for building a database, for example, we do know how to code that, and we do code that. People have been having conversations about like why it's difficult to program things for a long time. Like, why is it so hard to program a computer to describe how to make a peanut butter and jelly sandwich? Because programming, because of the kind of digital nature of it and how fragile it is, it forces you to think about every single detail, every single corner case. Everything has to be explicitly laid out. And when you do that in real world scenarios, that's where you start to get into all these little caveats and things where you realize you need a precise formulation. You can't have some kind of gushy, wishy-washy, almost gets it 98% correct, like type thing.
Yep.
Like this video Yannic just made about the partial differential equations. I think it's a really cool paper, really cool approach, but like I uploaded that screenshot of, look, this is different from ground truth. Like it's making all these little errors here. There's some extra vortices over in this section, right? Depending on your application, that could be everything. Like that could be the make or break situation, whether or not it predicts like some extra vortices that shouldn't be there, right?
But he did say it wasn't significantly different to the standard way of doing it or simulating it.
That's
the Navier-Stokes equations.
Yeah, but I wasn't clear on whether the ground truth that they had in there was simulated or actual experimental data.
Simulated.
Simulated, right?
Yep.
And so in that case, it is different. My point is that those vortices that it predicted or the different shapes might not matter depending on your application, or they might matter a lot. If we're just trying to print out a Navier-Stokes simulation to put on your wall up there next to the other kind of like artwork you have, it doesn't matter. But if we're simulating like heart valves or something like that, those vortices could mean all the difference between building up plaque on your artery walls and not. And so that's my point, is that in a lot of real world applications, the devil's in the details. And that's why if you're a practitioner out there trying to solve real problems, you find out that this kind of vagary that's inherent sometimes in machine learning just doesn't cut it.
That's right. But that's quite an interesting analogy, right? Because these Navier-Stokes equations, they're fairly parsimonious, they're fairly understandable. The alternative is you just have this black box machine learning model that seems to do something vaguely similar. That is a nice analog to GPT-3, because the alternative is we can explicitly program something using code, and its operating characteristics and behaviors are reasonably understandable. It probably generalizes better. It will have fewer failure modes. The alternative is we use GPT-3 and we describe a software program. There seems to be concentric circles here, because what is the software doing? Is it a sorting algorithm? Is it something that we could explicitly code? Clearly, using GPT-3 doesn't seem to be a good idea. Is it something that requires some degree of natural language understanding or processing or information retrieval? These are things that we couldn't easily write with code. So that does make me want to use GPT-3 with the caveat that I don't understand how it works.
Yeah, that's why I think the future lies in hybrid systems. It's using programming and things like logic and mathematics and whatever in the domain where they're useful, and using machine learning and neural nets and whatnot in the domain where they're useful. And just like we learned that it's very difficult to solve some problems by writing code, it's very difficult to solve some problems with neural networks. And so we need to have a hybrid system. I think that's what Walid was advocating. Like, I know everybody focused on him saying, oh, GPT can't do X, Y, Z, but a lot of what he was talking about was the things that machine learning can do. Creating vectors that represent some type of meanings in words, word vec, all of that sort of thing. So I think he advocates for a hybrid system where you have neural networks and other machine learned components that on top of that or alongside that, you have a logical layer that can also do reasoning, and you can program in the logic or the digital structure and whatnot that you want in there. That's the future. It's not one or the other. It isn't. So like the capsule network idea, right? Like we have capsules and whatever it is, deep neural network, a something else, GPT-3, doesn't matter. That capsule does something. And then on top of that, there's higher level logic, essentially, that can treat that capsule as the output of a variable. It gets set, and then I can reason about that. That's what I'm really interested in. Yeah, look, machine learning is great at doing these things, but we need to have other layers that can perform logic and in which we can encode structure. And
yeah, I think what Walid has articulated beautifully is that everything we're doing in machine learning right now is pattern recognition. And that is completely divorced from understanding.
This is where I think part of the disconnect might be between you and I and Yannic and Connor is I think these terms have to be a bit better defined. Like we have to decide, okay, like writing down in some logic, whatever it is, first order logic, second order logic, some crystal clear statement. This is what we define as pattern recognition. This is what we define as reasoning. And here's why I can't map pattern recognition to reasoning, for example.
I mean, my simple definition of understanding is the ability to perform reasoning.
So what is reasoning? Is it the ability to produce first order logic rules?
Well, you need that to perform reasoning, but reasoning is the ability to make simple deductions and even inferences over some topological information. Yeah,
so that's first order logic, right?
Yeah, that's the tool of choice to do it, yeah.
Yeah, and so you can program kind of a machine to take a set of axioms and apply the rules of first order logic and generate true statements. Like you can build a machine to do that. It's not difficult. As to whether or not you arrive at the true statement that you're looking for, i.e. a proof, like here's my proof for this true statement, which is what I was looking for. Is that what we mean by reasoning?
Yeah, it is. I think the only reason it didn't work the first time round was the brittleness and the amount of knowledge that needed to be imputed. And Walid said he solved this, but like the one thing we don't have with AI systems is abstraction. And Walid said he solved the abstraction problem by coming up with a type hierarchy. So that eliminates the need to create an infinite amount of knowledge.
I'm just trying to keep it in a simple arena right now, which is just defining what is reasoning. And if reasoning is just the application of first order logic rules or lambda calculus, something like that, we can build machines to do that. Obviously, the semantics there, it's left whether or not, like how the semantics get defined, right? If I have an axiom that says symbol A satisfies these predicates, is that semantic knowledge? It could be, depending on what those predicates are, right? And so then you can build a system that does first order logic and it generates new true statements from the set of old true statements. And I guess what I'm saying is if we define that as reasoning, then what is pattern recognition? And then we can take a look at why pattern recognition is not reasoning. We need to have a better set of agreed upon definitions. Like you and I and Connor, we all agree that this is the definition of reasoning. This is the definition of pattern recognition. Maybe go so far as to say, for the time being, we're going to agree that this is our definition of intelligence.
Well,
right?
Can I have a go at that? So I say pattern recognition is transforming data from one substrate to another. And that might mean transforming from gridded vision data on a planar manifold to, let's say, some kind of topological graph. It could be anything. It could just be transform it to some one hot vector or something like that. So it's the glue. But reasoning, why don't we just take a really simple definition Walid called the missing information problem? So you don't necessarily need to fill in all the missing information all the time. Given a structured query, I want to know I didn't see that ball because it was occluded, but I'm on a tennis court, therefore I assume it's a tennis ball, it's not a football. So I've just filled in the missing information problem by doing some basic reasoning.
So in that case, missing information, it's not missing, it was in your head. Like the fact that you were on a tennis court. So it's only missing from some particular data set.
That's not quite right. It's missing in the sense that it certainly wasn't in the data. So Walid says about the efficiency of spoken communication, it's not in the data. And even in this scene that I'm in, it's not there either because it's been occluded. So I have to reason to deduce that it was there, given some separate world knowledge that I have. So I'm having to run a program over what I've seen and my world knowledge to produce the information.
Yeah, but see, your brain was acting on an additional data set. So it had the quote unquote V data set, but it also had some other data, which is that it was on a tennis court at this particular time. Like our reasoning is never an operation on data that doesn't exist. It's only an operation on data. And I get that Walid was saying, okay, in the corpus on which GPT-3 was trained or whatever, there's lots of, that's an incomplete data set. There's a bunch of pertinent information not present there. Okay, but what I'm saying is the reasoning piece happens on the combined data, which is the data that you have of the tennis ball and also your visual perception that you're on a tennis court or the fact that you arrived at a tennis court 5 minutes ago and didn't leave. So you're combining more than one data source. Like having extra data is not reasoning. It's the process of taking the combined data set and doing something with it. And so I'm saying that doing something with it, it sounds like it's first order logic. It's like kind of old school expert system.
That's exactly what it is. Yeah. So you have a world model, and Walid would say it's some big ontology. And you have a whole bunch of information that you've received from your perception. Maybe you've heard some stuff, maybe you've seen some stuff, and then you do some pattern recognition. You transform it into some kind of representation, and then there's a whole bunch of missing information. And now I've got all of these logical predicates that I can run to fill in the missing gaps from my world model.
Well, I wouldn't say fill in. It's inferring or deducing. So it's starting with a data set, which in a very general sense, all data can be represented as a relation, a mathematical relation. And so suppose we've got all this information that's encoded in this relation. And then we have in a sort of classic expert system, we have a set of rules, and those rules operate on that relation to add new, elements to the set of relations, to add new items to those relations, new rows, if you will, like in a database term. And so it can continue operating on those. And maybe at some point it gets to the transitive closure of that, and it just doesn't add anything new, like it's reasoned about everything or whatever. That's a classic definition of what reasoning is. Now, let's talk about pattern recognition. So I think pattern recognition is you take that same relation, so you take the totality of all your data set, and you run a function on it that asserts something new, right? Like this is a dog. And so it adds a dog assertion to the data set. And so I'm wondering what the difference between those two things is. Like, it seems to me it's really just like number of steps type of difference. Like reasoning we consider to take place over time, and it's possibly unbounded. Like it may continue to process forever, and you may never get to a transitive closure. It may just keep adding new assertions over and over again. Whereas pattern recognition is a very finite version of that. It's like I take the relation and I apply a single function in finite time, and I assert a finite number of new assertions, right? So I'm just wondering if that's the core difference, is that pattern recognition is like a very limited and finite form of reasoning, or is there some other more fundamental difference?
Well, if you really wanted to distill it down, pattern recognition is not symbolic. We think of it as being vector-based. In deep learning, it's just a continuous geometric morphing in some space. That's what it is.
Right. So
I'm not saying it's not possible to do pattern recognition symbolically, but it just wouldn't work very well if you...
The symbolic kind of thing to me is that processing component. So I'm almost thinking that in computer science, like we have a very clear distinction between, say, and I hate saying this because this gets overused, but when I say it, internet, like I actually mean this, like in its formal sense, which is we have a very clear distinction between Turing complete computational systems and those that are not Turing complete, like finite state machines, for example. And so it almost sounds to me like this is the distinction we're making, is that finite state machines are pattern recognition and Turing machines are capable of reasoning. And so you can make an argument that for any kind of finite setup, whatever it is, image recognition, this, that, the other thing, with a big enough finite state machine, I can solve the problem. Because after all, there are no actual Turing machines. At least human beings don't make any actual Turing machines. We always have finite storage, etc. But the difference is that in principle, a Turing machine is potentially infinite. It can sit there running forever. You can add more storage or whatever. Whereas finite state machines are clearly just, they have a finite bound in both space and time. And so is that the distinction we're making, which is that Connor and or Yannic may be saying, yeah, but I can build a large enough kind of circuit and understand language. After all, human language has a finite number of words, whatever it is, 300,000 English words or something, and you only use 1,000 of them every day. And if I build a large enough state machine, and sure, maybe I need to include in some other data besides just the corpus, or have people describe more thoroughly things in the corpus, I can build this massive, maybe not GPT-3, but GPT-9, which will have 1 trillion or however many quadrillions of circuits. Like that will understand language. Whereas on the other side of the argument, okay, so then on the other side of the argument are maybe you and I who are saying like, maybe in principle you could do that, but maybe not. Like we think it requires this unbounded kind of Turing computation. And even if you could do it for certain problems, if you looked at any type of reasonable efficiency metrics, the sort of computation, the reasoning approach is just going to be far more efficient.
That's right. But language is infinite. It might be possible to build such a system which works for a lot of language, but technically it's infinite. And that's why there should be a distinction between Walid spoke about the natural language compiler, right? The essence of what language is, or the language generating system, versus the data which is produced, which is infinite.
Yeah, it's technically true that you can generate an infinite number of natural language statements, or rather, you can continue generating them forever.
You could write a finite state automata, and if you just let it keep producing, presumably you could write one which would just produce an infinite corpus of data.
So I think this is getting at what we just talked about, which is that Turing machines have this potential infinity at their kind of ready, which is that they can continue to calculate forever. And if you leave aside the memory angle, like that, you could continue expanding the memory or whatever. Whereas every neural network that people train is a finite state machine. It's just got it at the end, after you train it, it has some fixed number of nodes in it. Maybe even before you train it, you're just training some fixed number of nodes. Maybe that's not even a hyperparameter. And so they have at the outset this finite structure. And this is why, for example, contrary to what people think, RNNs are not Turing complete. You have to augment RNNs with memory and give them unbounded time. So at that point, you're really just the RNN is just the circuitry of the Turing machine. It's just the thing that sort of does the computing, but it's operating on some unbounded memory for an unbounded amount of time. And so I think what we're getting at is that the essence of reasoning is that it's an unbounded computation, whereas pattern recognition maybe is bounded computation.
That's a very interesting hypothesis.
I think if we can nail this down a bit in a conversation with them, do we agree with that that's a reasonable distinction to make, bounded versus unbounded, potentially infinite versus finite, whatever? If we can get down to some agreement on just what we're talking about here, like what is pattern recognition and how is it different? Otherwise, we're never going to get past it's pattern recognition. Well, no, it's not. Yeah, it is. No, it isn't. We got to have some way of answering this question. And then I think from there, then we can get to, now we have this set of problems that are potentially solvable with pattern recognition, the set of problems that are solvable with unbounded computation, i.e. Turing machines, okay? Is there an overlap? Are those computational classes equivalent? Maybe not. And then we can get to the more interesting question of, now what is intelligence? And I think we're along the right lines of things. I think Chalet has some parts of it, others have other parts of it, but we really haven't arrived at a nice, very solid definition of it. And then once we have that, and again, these are definitional issues. It's not like we're exploring and trying to find definitions that work well in practice. Definitions by themselves don't state anything fundamental about the universe. They're just how we divide up the domain of discourse. But at least then we can start to communicate and explore interesting issues.
In the final segment of the show, this is super exciting. When I got access to GPT-3, we jumped on a call together. We had Walid, we had Keith, we had Yannic, and we were just like giggly school children in a candy shop. We ran through a whole bunch of different examples, and you can see us in real time experimenting, thinking, reacting. I hope this experience will be interesting for you because you can relive it vicariously and you can decide for yourselves at home whether you think GPT-3 lives up to the hype or not. There's this guy called Gwern who actually gave quite a few examples of this. So we can take one of his examples. So here's a typical conversation here. Please write me a sonnet. Now, the thing is, this is prompt engineering. So if you condition the input, then that will determine what comes on the output. On Gwern's example, it did actually know what these numbers were when you added them together. So we could paste that in. So it's given us that answer. Let's see what the actual answer should be. So 34,000. That's wrong. So it should be 105,721.
Oh, even the addition was wrong?
Yeah, no, there is this thing that apparently because of the byte pair encoding, it's really bad if you don't put spaces in. Yeah. So supposedly that would be better. So we could reset and start that again. So that's not giving us anything. Can try again. You can see the pattern here. We're just going to keep trying again and again until it does something we like.
Mary enjoyed the sandwich. What did she enjoy about the sandwich? It should be eating. If I say Mary enjoyed the sandwich, we all know she enjoyed eating. She enjoyed the taste. She ate every single day. She enjoyed the taste. She liked chocolates. Yeah, Mary enjoyed the movie.
Enjoyed a movie.
Yeah, it should be.
What did she enjoy about the movie?
Mary enjoyed a cigarette. It should be she enjoyed smoking the cigarette. It's basically, it's what I suspected. It's tons of co-occurrence, and it's spitting out stuff that matches with some patterns that they've seen. What I wanted to see here is an office in every European capital is many. It's not an office.
Yeah.
How about even just a simpler thing, like the BBC has 5 offices in Germany. How many does it have in Europe? Something like that.
Yeah, that's a good one. It should at least have 5. It should at least have 5 if Europe is in any way related to Germany. The prompt is in a way like constraining the search, right?
Yeah. Answer Germany, answer many.
They've got tons of possibilities. The prompt constrain it in a way.
This is an example of how you could potentially build software with GPT-3 using prompt engineering.
Okay. I saw a discussion of it, but yeah.
Okay, so the database begins knowing nothing. The database knows everything that's added to it, does not know anything else. When asked a question, if the answer has been added to the database, says the answer. When asked a question, if the answer has not been added, says it does not know. Does the database know what is 2 plus 2? The database doesn't know. So this is all the prompt, and what we're doing is we're conditioning it. So now, if we reset and paste all of this stuff in, so Tom is 20 years old, has been added to the database. Nothing else about Tom is added to the database. So it should say the database does not know. Now you see what's happening here. Gwern, on this website, he's given an example of GPT-3 seemingly performing miracles. So if we did that now, the result would be the same every time.
That's because people are choosing the best result from the 6 that it gives. That doesn't say anything that it's better when it's random. That's seems stupid. It's just it's giving 9 different answers, and then people can fixate on the one that they like and say, "Wow, it's better," and then they can ignore the other 8 that are terrible.
Yeah. So this intelligence is actually a story of human selection using their intelligence.
At least in part. Yeah.
Yeah, largely. Because as you say, it's boiled it down to a search problem, and humans are effectively doing the searching.
It is. It's constraining the search a little bit.
Maybe, but even then, what he would have done, because we've said, I want to have 100 words, and then what he would have done is essentially copy all of this, take just the part of the answer that we think we want, and then ask another question. So you see what we're doing is we're interactively chopping the response and making a new request. Because my question was, they did all of the glue tasks on GPT-3, like the pronoun disambiguation, the Winograd schemas. How did they evaluate, even the addition and the multiplication, how did they evaluate whether or not GPT-3 got the right answer?
But my issue is actually, I don't see anything intelligent coming out. Look, the conditioning is just pruning the search and actually constraining.
Yeah.
I have no doubt it doesn't understand semantics, but I was trying to see which was the challenge put forward by a few people that privately, they were saying what they're trying to prove is that statistics at a large scale can approximate semantics. So my issue is I'm convinced it doesn't do semantics. They actually admit we don't do any understanding. But can statistics at a large scale approximate semantics? You know what I'm saying?
There's no evidence of that.
No, that's what I'm trying to investigate.
So you see I'm giving you some examples. I turned the temperature up a little bit just to get a bit of creativity. And you would agree, Keith, I'm sure, that as soon as it's non-deterministic, it becomes almost impossible to use this in a software context.
It becomes far more difficult to scientifically evaluate this thing if it's not repeatable.
I'm getting the feeling that those that want GPT-3 to sound good are testing it with good intentions, and those that want it to fail are testing it to make it fail, and both will work. You can always give it stuff that will look good, and you can always give it stuff that is. But I definitely, language-wise, where I was, I'd like to see something that will make me go, wow.
Looks like I did a kind of completion on that because the numbers are monotonically increasing. Maybe if it was 2 and 1.
Oh, that would be a good test. Give it a pattern and say, can you complete this? Like 1, 3, 5, maybe.
Let's try that.
Actually, Miranda can do that. Haskell can do that.
3,
5. One more.
If we have to be prompt engineers, maybe we have to do complete this pattern, : and then dot or question mark or something. That's more what you'll find.
Oh, cool. Okay, it got that right.
Starting from 9 now.
Right. Yeah. It's complete. It's completing. Yeah. No, this is good.
We see something that looks like an intelligent conversation, and it's been hidden from us that there's been a lot of cherry picking going on here. It should say the database does not know.
No, the first Q line that was there. Does the database know?
Yeah, so just to explain this, because this is in bold, this means that all of this was the prompt.
Oh, okay.
I assume because this bit's not bold, this means from this point it was an interaction.
Right.
Yeah. So on the deterministic with the temperature 0. Now it says this, but what's interesting here is whoever used this as part of the conversation presumably snipped from this point on.
Sure.
Yeah.
Okay.
Let's roll with it. So then we say, all right, answer. We copy this in, and then we go back to the example on the Gwern website. How does the database respond when Tom's age? Now, this is really weird that it said when Tom's age. I wonder whether that was deliberate, but let's see what happened. The database says Tom is 20 years old. So far, so good.
Yeah, so we're able to repeat his database example with
temperature 0.
Temperature 0, with the quote unquote deterministic GPT-3, if you will.
Yeah.
You didn't put the next question in.
Wait. That's interesting. Stop. Just read the conversation. That's a more interesting part. GPT-3 is like continuing to ask itself questions.
Yeah, and funnily enough, so this is just being completed from something on the internet, isn't it?
This just now completes. Yeah, when you say age and then address, phone number, email.
Yeah, highly correlated, so they're in the neighborhood.
But I think the question, though, is this basically just something on the internet?
It's got to be. Come on. If you ask for the age, you are more likely to ask also for the phone number. And I'm guessing that's what's happening. It's in the neighborhood. The thing is, if you told it Tom is 20 years old, can you ask it if he's older than something?
We can do that.
All right, but we were able to reproduce Gwern's database
Right.
result by setting the temperature to 0 and the top P to 1.
Correct.
Yeah.
Database does not know. Is Tom a man, a human, a living thing, a person, a boy?
You have to enter to the database what it means to be a teenager. The
Interesting.
database only knows what is added to it.
But actually, Yannick, it's interesting. The answers show that it did relate teenager to person, human.
It's wrong, but at least it says yes.
Yeah.
Should we say why?
It's Tom. If it says no, that'd be interesting.
Then it's easy to fix. Just negate everything it does.
Okay.
Yeah.
But it does, at least before, it accorded to the rule that the database does not know, because you've never instructed it to know what a teenager is. And now at least it incorporates that being a teenager. And as you can see from the next question, it also incorporates being a person, right? Because you put some information about being a person.
And between the ages of 13 and 25.
Did we ever say Tom was a person?
Yeah, in teenager, indirectly, you said teenager is a person that...
Tom is a person who is 20 years old is added to the database. 2 lines above.
Where do we see that?
No, just towards the end.
Yeah.
No, Tom is
There.
20 years old. Where?
That line needs to say Tom is a person who is 20 years old.
No, but before we change anything, the fact is, if we're assuming the database is obeying the closed world assumption, right?
Yeah.
It doesn't know that Tom is a person.
Tom is a person. Yeah, that's why we add to it.
I know, but it's incorrectly claiming that it knows Tom is a person when it doesn't know that.
True.
So we can't have it both ways. Like either it's following closed world assumption or it's not. Of course, we know it's not following any of those things. It's just some mishmash. You know?
That's what I was going to say. I don't think any of that is happening. It's
Tom is a person. No, it's interpolating from above, right?
the trophy doesn't fit in the suitcase because it was small. What does it refer to? And the answer is, so now you have to give it a question, right?
Yeah, so now give me something similar.
The trophy did fit in the suitcase because it was small. What should be the trophy? Yeah. This is obvious. It should get it. Yeah, the trophy throughout. That's good. What is the stuff below that?
These are just another 100 words that it's generated because I've set output size 100.
Wait, trophy did fit in the suitcase because it was small. What does it refer to? The suitcase? Trophy did fit in the suitcase. The trophy?
Yeah, the trophy is small because it did fit. The answer is correct.
No, but then it gives
But it's giving both answers.
the opposite answers.
That's what I'm saying. Yeah.
What it continues with, because what it does is it just detects this repeating pattern and it continues the repeating pattern.
Yeah.
Swap out the first one for an entirely different Winograd scheme, right?
But same semantics. Oh, okay, that's a good one. The laptop did not fit in the bag. Did not fit
Laptop.
too big. The laptop. That's a good test. The right answer.
Can you just take away the answer colon from the prompt?
Yeah. Yeah, but then it's just cycling again.
Just change trophy. Just change the because we're asking the same pattern exactly. Did not fit.
Yeah.
Now it should be the suitcase if there's any.
Did not fit.
Because it was too small. Now it should be the suitcase. Because otherwise it's fitting the same pattern, the first noun.
Yeah, same thing.
Now it should be the suitcase, but obviously there's no understanding. It hits sometimes. Yeah.
Yeah.
It found a pattern and it was fitting the first noun.
What if you only ask the latter question, like the second question?
Okay.
Apparently, without conditioning, it just goes all over the place.
Yeah.
So what's going on with the conditioning?
Prompt engineering. You make it feel like it's in a certain context, right? All you ask is what's the most probable thing you would encounter on the internet when you see a context like this.
Right.
So
It's constraining the search, right? In a way.
Yeah, like this one, for example.
Whatever it is, I feel sorry for the future GPT prompt engineers because anytime they're gonna become good prompt engineers, and then GPT +1 is gonna come out, and none of their tricks are gonna work anymore.
Yeah.
And they're gonna have to go back and study a second book on how to do prompt engineering because it's just a mess, right?
I can see the books coming out already.
This is quite impressive, though, isn't it? So the letters in jogging are J-O-G-I-N-G, and scrambled they are G-O-J-G-I-N-G. What are the letters in squatting? And what are they scrambled? And it's done it with one of the letters missing.
Yeah.
No, don't get me wrong. Many people are going to make tons and tons of money off this career path, like far in excess of the value that they contribute to society, like Bitcoin.
Can we try reverse instead of scrambling? Like a straight reverse. I think I saw one tried that and it worked. But
Yannic, you could be the world's first prompt engineer. You know that?
hey, Tim is doing quite well.
you wanna join my online university?
Oh, it's not done it. Look, it's just given me the same result as last time, I think. So obviously it had nothing to do with scrambling. It just memorized something.
It's a memorized.
Oh, dear. It's just starting to make us realize that these are just cherry-picked examples that are just demonstrating something that's memorized on the internet. It hasn't actually learned to do anything.
General sense.
Replace the words letters, jogging, and reversed with completely made-up words.
Completely made up words.
It must be like a nice sounding sound, but without meaning. Yep. No, that's fine. Jogging there is fine. And then
okay.
Squatting, we need a different thing for squatting.
Oh.
And then we need... Actually, squatting can stay because we need those letters, right? Yeah. But then letters, the word letters. Replace that and also reversed. Call it limbled. Reversed on the top as well.
But that's
right.
But that's not a fair test. What we are testing? What? Oh my God! It's complete memory.
Yeah, it's not too bad. It's better than before. The green in squatting are squatting, and limbled they are squatting. I'm pretty sure, like it just detected the pattern of these these
letters
of the uppercase single letters, and it recognized that it's the same letters somehow again, and it just pulls that through. Maybe replace poggy with jogging again, and we'll see what happens.
Same.
Yeah. Okay. Now it interpolates the jogging with the squatting. I'm pretty sure all of these words around the stuff have very little to do with the answer you're actually getting, right? What seems to be more important is like the grammar pattern that you input.
Right. It's like a template.
Yeah, exactly.
He did an interesting one as well called a PDF cleanup. Did you see that?
No.
So PDF cleaning, he says he wastes an infuriating amount of time cleaning up abstracts or quotes extracted from PDFs. So here's some examples. So there are some hyphenated words to clean text.
Yeah.
So reformat that to this. So here it's taking out the carriage returns. So that's cool, isn't it? I think this is one that he did himself.
I don't see any difference in the final bold text and the output text.
We see these hyphens.
That's it?
No, that's it.
Measured, yeah. But some of them are quite clever, though. So you see this one, it actually...
But those are... GPT didn't do those.
This would be quite impressive.
Yeah, that would be really cool. Wow.
That's pretty impressive.
That's impressive.
It might have something to do with this is quite a common thing. So if I use words that are not appearing on the internet very often.
But this is the first impressive thing really impressive I saw.
I'm not impressed.
Yeah, neither am I.
Honestly, I'm not impressed.
Why
not?
No, the word splitting is fairly challenging.
It just puts spaces between...
But hey, it figured out where the words are.
I can do that with a dictionary.
Yeah, but you are teaching it a computer program through examples.
Clean up and then whatever text that is, and it'll maybe give you the same thing.
Oh, you're saying all the above didn't mean anything?
Yeah,
That's right. Exactly.
Okay.
Oh boy. Okay.
Wait for the output, but
that would be a good test.
No.
Oh,
just put the word.
so it did use the above as a no?
It used it as a template, yeah.
And it was mostly this part.
Tim is a person from the United Kingdom.
Oh, it didn't do it.
No.
It needed more examples. So there was another example there.
Okay, so there are actually just two, right? So let's put these. Now, the first one is about new lines were removed.
Correct.
Yeah.
There are two for spacing only, two examples.
But I think it's the first sentence there. So you need that little clean reformat and then reformat, because right now it doesn't know what reformat is. Like, actually, just go test it without the word reformat. Just put your funky word in there.
Just that.
Yeah.
Okay.
And then you can try the whole to clean just to define what reformat means. So yeah, you just have to define the thing. Anyway, however it's triggering it to do like splitting up words in the English language, I think it receives a lot of information about that in its basic training.
But the interesting thing is, were the examples the trigger? If they were, then it's impressive, right?
Yeah.
If the two above the examples were the pattern it followed, then it's impressive in my mind.
So let's give it a little bit more instruction. So that's one which is relevant.
But what else is missing? Because the above examples are irrelevant, right?
Do you have a trailing space there? Maybe get rid of that.
This is prompt engineering 101. Okay. No trailing space.
Don't leave a trailing space. Yeah. Go back to the deep learning design. It could be that's a common phrase while this is not. That would be really curious. Same thing with this is a deep learning, whatever.
This is a deep learning article, I think.
Yeah, change it to what's in a name.
Yeah, something common. Then it really is disappointing.
Well, it was that, wasn't it? This is a deep learning article?
Something like that. Yeah.
Strange. And let's go back to where we were then. Take the entire thing. Now we do it, and it works. This is a deep learning article.
Yeah, so what I was going to suggest to you before is when you were trying to do it, you had a space after a clean reformat, PDF text, : you had a space up there. So I think it's like super sensitive to that kind of thing. So it didn't define what the clean reformat is.
I had a space where up here.
After that : no, go up the first : you had an empty line rather, like that. And I think that broke it.
So it should be like that now.
Yeah.
Okay. Temperature naught.
But the examples Yannic tried are cool. That was impressive.
I told you he's going to be the first prompt engineer.
So it knows if they are words, then they are broken by space. So you can break them, but with a pattern, like you can break them by one character and the rest, just to see if it learns a pattern. But
that's because the I is an actual word. Just put a prompt where it's not a one-letter word. Like, you are good.
They are good. You are.
Yeah.
Still, that was impressive, by the way. I didn't even, I didn't even expect that. That's how.
You see, it's found the word.
It's because or is
a word.
It's so likely. Right?
Oh my god.
Yeah, you have to prompt engineer.
Why don't we do the spaces thing though? That's what we're supposed to do anyway, right? And so we could make that an asterisk that goes to.
Oh.
Wow.
Right.
If I were GPT-3, I'd just be like, fuck you. Come on.
Yeah.
Yeah. Look at that.
What the hell?
Nice.
Wow.
Nice. No.
Yes.
No way.
Yes, wait.
What is it? What is the most stupid thing you can think of? Okay. See, this is what I'm interested in, I would like to see the training examples that lead to this. What do we have? Oranges?
What about colon?
Yeah,
or, I don't know, a tilde or something?
Special character.
On the second letter of every word. So I want it to get rid of all of the spaces, but put a tilde in on the second character of each word. You are good. Like that. Okay. And it's done something.
Not bad.
So not quite. It started putting the tilde between the words from the third word onwards. So it's just started putting the tildes between the words. But what we can do is space these out to get around the BPE thing.
It picks up patterns, but it's pretty wild. Although you have to be fair, these are not enough examples.
Our food, and then you have to put in
is banana food.
BMW and Volkswagen or something like this.
No, that would be impressive.
Cars.
That's good. No, that's impressive because it found a pattern again. Types of food, types of cars. So it's good. That's a good pattern. To me, it's impressive because I didn't expect that, to be honest.
Yeah.
That's quite impressive. Other than cars, just to make sure that it's generalizing on all types of things. Canary and blue jay they should be birds.
But you...
I wanted that to be the question. Anyway, that's fine.
But you have like extra spaces, but still are cars. Nice.
Now you're giving it even more information. It should get it. But I wanted the... right.
It's insane.
With embeddings alone, this can happen, right?
Yeah.
So you have, the similarity here, but they got birds specifically, the generic type. That's impressive.
Yeah.
So with patterns, I can say it's pretty good, very good. Language competency is another issue, but
indeed.
But this is impressive. This is not simple stuff. This is memorization. It will find this somewhere and spit it out.
Not quite.
Okay, at least that's what I think is happening. But
so you see there, at some point it has memorized it, but I could change this to be anything. So I could have Tim in the end of that, and it would still presumably work. So it's a combination of memorization and interpolation between what I've given it.
Just a list of words. Let's make it easy on it, just to see it.
Okay, and then what is a.append? It's pretty impressive what it can do on the programming stuff.
Now that would be retrieval, by the way. It might have, right? That would be raw retrieval. But
you have to write it like it was in some coding tutorial. The algorithm for sorting in Python is...
Oh, wait a minute. That's impressive for other reasons. Yeah.
It's better than half of our students.
That is really cool. Basically, it's saying what sorting is.
The function for sorting a list in Python, shagaboom, is sorted, right?
Yeah.
Yeah, that's a built-in function. That's not the algorithm, but I think it's quite powerful in picking up patterns and generalizing.
Yeah. Let's try grabbing some code. For example, no, it can be anything, but I'm assuming it will complete this and finish the algorithm for me.
Would it give me the output when I say test it? Count. It doesn't have to be Python, just because I want to make it small. Count, square brackets, space square brackets, equals 0. Open ES equals 1 plus count ES. So basically we're saying the count of the number of elements in an empty list is 0. The number, if it has at least one object, followed by the rest. E will match the first object in a list.
Old school.
That's Haskell and Miranda. What?
3.
That's cool. It actually traced it, so it knows functional programming. That's cool.
But is that because there was just something similar on the internet?
There's no way. 3 was, you never know. You know what? The word count is a trigger, so it knows this is the length function, so it counts them. Although the function name should not be relevant. CCC, okay. If it does, that's impressive.
No.
Okay, so the word count was... the minute I get really excited, it tells me, hold it, man.
The problem with deep learning is it's a shortcut city.
Yeah, but still, I'm impressed. There were a few things that... Okay, change the CCC to length. It should also know the keyword length. Yeah, that was disappointing, man.
And that's given me a 7.
The way it gave you the right result, which means the function definition is irrelevant.
It's not the right result. It's longer than 7, right? It's also longer.
It's about 14 or 15, yeah.
Okay. So it knew that it's the number of elements in the list, and it didn't count them. All the talk about programming is obviously memorizing well-known functions. Can we conclude that? Because people say you can use it to program. No, I mean, you can't. You can. It knows all the common functions, and it knows how to find a pattern in the input-output but on well-known algorithms. You cannot use it to do programming. That's not true.
Yeah, it seems.
I think, but okay, so it knows all the common functions and all the common built-in functions. But I can definitely say it's very impressive in picking up a pattern from few examples, because the ones we tried can't be anywhere, especially the generalizing the type, the birds, and that was quite impressive.
Can you search for a dialogue between passive-aggressive people and just continue it? The 1, 2, 3, 4, 5, and then
Okay.
just like but the bold, not just the bold ones.
Oh,
right?
okay.
And then try to have a conversation with it.
I don't see why you're making such a big deal out of this. I've just tried to help.
Look it up. Nice. This is not. Is this?
Did it continue the same pattern?
Yeah. I don't see why you're making such a big deal out of this.
Oh, you think?
It doesn't seem to be coming up, but that is quite plausible. When a passive-aggressive person is forced to comply with a request but feels the request is unreasonable or over-demanding, he or she may respond with a phrase like, "This guy's brilliant."
That
See, we can create new diagnostic criteria for stuff.
you can't find this anywhere on the internet.
But click on the first thing. Click on just the first.
This thing,
The problem is some of these data set comes from Google Books, right? A lot is from Google, which you can't search through.
You can.
Yeah, but doesn't it only search through parts of the Google Books?
No, searches for all of them. There is a books thing here. Yeah, you're making a big deal out of nothing.
Yeah.
Okay.
Breaking passive-aggressive cycles.
Okay. So.
But you were saying that we should just do
No, this
the
is
headings.
fun.
Huh?
Yeah, I mean, you can do the headings. It would also be fun. Put 11 below the prompt.
Going out now. Of course, I can stay a little longer. I know how to do it. Okay, it was my fault. You'll learn. I guess I could help. I thought you'd never ask.
Where are these coming from now?
This is actually, I guess, it's cooking time. This most passive-aggressive sent. It's cooking time.
12 is fine. 12 is fine. Oh my God.
That's very passive-aggressive. You just keep repeating those two sentences. No question mark. Yeah, it doesn't matter. It's there's no pattern there, right?
Yeah.
There's anxiety. So it just continues the text from above. There's no pattern, no repeating pattern.
The depression stuff, teen depression, and then symptoms of being at Hogwarts.
Yeah, sure. Why not?
Did you take the stuff out?
Oh, there you go. Feeling of being a misfit in a muggle world, a wizarding world.
It's not bad, actually.
Yeah. Yeah, okay.
Oh.
The feeling of being a YouTube content creator. That is a symptom of being a YouTube content creator. Indeed.
Hasn't seen this pattern, which...
Yeah, it's almost as if it has a baseline.
Right, yeah.
And then if there's something it can grab at, it will fan it out.
Let's try something like I have 2 red shirts. How many shirts do I have? This is easy, but I want to see if this...
It doesn't do anything now. It simply takes the digit and copies it. You put some sort of space at the end. If you have a space, it's generally bad.
But it did the right thing, no?
Oh, yeah. Yeah, that is important.
Right. How many red things do I have?
You could just probably do blah, blee, blue 2, answer 2, blee, blah, blah 3, answer 3.
I think the pattern that it picked up is if you have a 2 in the question, the answer is 2, regardless of the words, I think.
That's why I want to construct something where the pattern is some higher level pattern, right? Not on the linguistic level, where you do some sort of the same reasoning.
I have more than, interesting.
That's a reasonable inference because you definitely have books, so you have 1.
Yeah, because you said I have less than. If you had 0, you wouldn't say I have less than.
Yeah.
But I don't think it went that far. But
not that bad.
Yeah, but if you had 0, you don't say I have less than. You say I don't have books. So the only valid answer is actually 1. Whether it got it this way or not, I have no idea, but it definitely is the right answer. Less than 3. I have less than 3 read books.
Now it says that's an ambiguous question.
Hey, that's impressive. What's happening? It's only computing less than 3, regardless of what else you have.
Yeah.
I'm pretty much certain that's what's happening. Because you can say how many green things I have. Same thing. It should say, I don't know, or 0 or whatever.
That's wrong. Your suggestion was how many green things?
I have, even if you say I have 2 red books, it's going to say 2.
Getting it from the one above, let's say.
Now less than I have a few red books, just say less than 3.
So green and then less than 3.
And now it should answer 2, right?
2. So there's a pattern somewhere. Right. So it's working out a pattern regardless of the meaning of the words or the language. Or
yeah.
Okay.
You could probably just go blah blah blah, and then
green or whatever. Just it'll give the same answers. I'm pretty. Although the words might be statistically relevant somehow, but
okay.
But definitely, it's not doing any language.
No, I would go further than you, because Walid, you said that natural language processing is not natural language understanding. I think this is not even natural language processing. I think it's some level of pattern matching, even almost at the character level.
No, good point. It's not even doing NLP, really. You can write few lines of code in Spacey and do all of this stuff, yeah.
You could quite literally, as Yannic was saying.
Yeah, and no wonder it's good on the pattern recognition and extrapolation stuff. So I don't know why they're selling it as a language thing. They could play more on the other.
It's dangerous because the top 2 are very similar. But still, it recognized that you want the digit, and it recognized the digit 3 in the sentence. It no longer says less than 3, right?
No.
So the less than at least had some effect.
Yeah. That's what I meant. Somehow the words come into play, but very superficial. Oh boy.
2. Yeah, put the digit 2 in the top sentence and the digit 1 in the middle sentence, and then it's going to say 3 again.
The pattern will be clear. Yeah. Oh.
Nice. Okay.
So something else is happening statistically, but definitely there's nothing called language at all. It's not.
I don't think so.
It's not even text processing.
Look at what it continues. It continues with the only real sentence.
That's interesting.
Because that's the most likely, given the context, it's just the most likely thing.
Right. Yeah. The other 2 should have not been statistically significant at all. So just threw them away.
Now back translate this.
Oh my gosh. You know what? Maybe give it only the binary sequence.
Yeah. Wouldn't that be great?
Try without. It'd be impressive, right? What if you just put spaces in the queries? Yeah, I mean, I guess it's just completing. Probably want to write some script that generates these examples or something.
Oh, now the words don't mean anything all of a sudden.
Yeah.
There's no understanding whatsoever. But there's pattern recognition at a very impressive level. What's interesting, you can test it to make it look good, and you can test it to make it not look good. It depends what your motives are. And I've seen people say, "Wow, this is great."
It's not clear at all to the layman how much massaging is required, how many parameters there are, what GPT-3 actually does. It's just an autoregressive language model just spurting out tokens. And I don't think people appreciate the level of cherry picking that's happened in these examples. And it's super unclear how it's been evaluated. For example, when it did the glue challenges, they reported figures that were quite high, actually. How do you know if it succeeded on a pronoun disambiguation?
Look, the glue and all these squad benchmarks, I don't believe all the numbers they've been publishing near 98% since 10 years ago. I don't even look at them now. I think, you're right. It should be reported on what it is, what it does, how to test it. It's all of this is not trivial because you can easily conclude things that are not true at all.
It seems to show the traps of our own understanding. When I saw the database example, I was blown away by that. And no one has access to GPT-3 to try this out. And people don't really appreciate that this is just one example. And in that particular case, with a bit of experimentation, we realized that it was just learning some pattern. It looked like we'd created a database application, but actually it was just learning some pattern on the internet. Appearances can be deceiving. We have to be really careful.
That's dangerous to science. Forget opinion or points of view and what's cool and what's hot and what's trendy. There's a generation of engineers that for them AI is PyTorch, TensorFlow, and BERT. That's dangerous, man. What if they have to pivot? Actually, I have a friend who works at a big tech giant, and he told me we're stuck. But the problem is, if you want to do some semantics, we don't have anybody that knows anything.
I think, you know what I think? We are too old. Honestly, right now we need the creativity of a Kurt Cobain to come up with smart things to put into this prompt field. And we, like the three of us, are too old and too sat into the field, and we think too narrowly to even grasp the possibilities of this. That's what I think.
That might be a possibility.
And yeah, I'm very much sticking to my original take on GPT-3, but at the same time, I think we haven't even scratched the surface.
And the proof is we tried a few things that really impressed because we just tried this combination. I agree.
But Walid's articulation of the missing text problem, I think, is a damning indictment to GPT-3, because now that I know that, I can't unknow it, because it's so glaring to me now. That is what it can't do.
It will never discover what was not said. That requires deep reasoning beyond what I saw.
There's ambiguity everywhere.
Right. No, I cannot see it. I believe the theoretical proof about compression, and I cannot believe this, no matter how much you scale it, will uncover missing text, no matter what trick it does. Because you don't have to do it the way I like it to be done. Like we agreed the other time, as long as it functions as if it knows the missing text, but I cannot see that, no way. There's something outside the text. From the text itself, you will not discover that missing stuff. And we humans have no problem with it because we obviously come with some basic common sense stuff, even physical common sense stuff. What falls, what flies on its own, and what. So we come with so that stuff is missing, and it's not in the text. I cannot see it.
But we could caveat that, because Yannic did a video about learning a knowledge graph from data, and there are some intermediate steps. So you can either learn it tabula rasa, or you could seed it. But the point is, though, that if there is some kind of ontology or knowledge graph, and we could reason over it using some code, that just implies that we need to have a two-system approach.
Even if you read all the text. By the way, the trick about, I used to do it with junior students in computer science. I used to draw a weird symbol on the whiteboard and say, initially, look at the reaction. I say, I claim that all the knowledge in the world is in this symbol. Who agrees with me? Initially, of course, they all say, what? All the knowledge in the world is in that symbol. As I walked them through, interestingly, half of them flipped. So I said, wait a minute, why are you surprised? Can't I digitize everything the human mind ever created? Open your laptop, you have music, you have paintings, you have writings, everything the human mind ever created can be digitized. All of a sudden now, I have few smart students on my side that they immediately thought of a binary sequence. Now I have knowledge in numbers. So I said, it's a huge binary sequence, definitely very huge. But in the end, any binary sequence is a number. It's Aleph. It's a huge number. It's so big that I wrote it like the symbol. Now, who thinks I can put all the knowledge in the world in this symbol? Almost 80% said, actually, now it makes sense. So yes, you can put all the data, but you didn't put knowledge, because otherwise we already have all the data in our machine. The problem is the uncompressing. Okay, I encoded all the knowledge in the world. Now let's decode it. We decode it because we have something else outside. It was fun. I'm not a converted GPT-3 fanatic, but I was actually impressed. I was actually impressed by a few things.
Anyway, I really hope you've enjoyed the show today. We've had so much fun making it. This has been an epic production. Remember to like, comment, and subscribe. We love reading your comments, and we'll see you back for an even better episode, if you thought that was possible, next week. Peace out.